Hello there and welcome back to the Sleep Science. Tonight you're not lying in bed on some random Tuesday, you're floating weightless inside the very first seconds of everything that ever was. The air, the warmth, the light outside your window, all of it once fit into something smaller than a grain of sand. You can almost feel the hum of creation in your teeth, that low cosmic throb that says something enormous is about to happen. You probably won't survive this, of course, most matter didn't, but that's fine. Tonight, Monsieur Moitz, you get to watch the universe be born. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Tell me in the comments where you're listening from and what time it is. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The dark stretches forever, but not the cold. A spark forms, no, not even that. A fluctuation, a wrinkle in nothingness. In an instant, energy becomes matter, matter becomes dust, and the first ingredients for stars, hydrogen and helium, spill into the void like flour onto a kitchen counter. You drift through it, light as thought, surrounded by endless gas swirling without purpose. Gravity, still new to its job, begins gathering the particles. You feel it tug at your edges, a slow invitation towards something resembling structure. Billions of years compress into a single shimmering heartbeat. Tiny knots of gas grow heavier, spinning faster. The temperature climbs. At 10 million degrees, hydrogen nuclei collide with such force they merge into helium, releasing light, actual blinding light. The first stars are born and suddenly the universe isn't silent anymore. Their glow spreads across the emptiness like lanterns in fog. Historians still argue whether calling this the end of the cosmic dark ages is poetic license or legitimate science, but either way, the metaphor fits. You float near one of these infant suns, close enough to feel the radiation buzzing across your skin. It's not quite the cozy warmth of a beach day, more like standing in front of an open oven door the size of Jupiter. Yet somehow it feels familiar. After all, the atoms that will one day make up your bones are watching this too, scattered in the dust all around. A historical fact hums through your thoughts. About 380,000 years after the Big Bang, light could finally travel freely through space for the first time. Before that, everything was a hot plasma soup. No photons escaping, just constant collisions. It's strange to think the night sky once had no stars, no shimmer, nothing but seething brightness trapped inside itself. And now you can see those first stars flickering, their fusion fires shaping the future periodic table one proton at a time. The newborn cosmos is not peaceful. Each star is a miniature factory running on pure chaos. You can almost hear them hissing, hydrogen atoms crushed under pressures billions of times greater than Earth's atmosphere, forced to become helium in a desperate attempt to stay balanced. The process, known as nuclear fusion, will power every sun that ever lives. A simple reaction, yet it defines everything. Stars, warmth, chemistry, life. You might call it the first universal law of coziness. Convert mass into energy and hope nothing explodes too early. Of course, some things do explode. Tiny, unstable stars flare out before they ever settle down. They wink on and off like faulty fairy lights in the blackness, each failure supernova scattering a little more matter into space. It's a cosmic version of trial and error, except the errors could melt entire galaxies if you stood too close. A quirky side note, some astrophysicists believe miniature population 3 stars, the first generation, were so massive they burned out within a few million years, leaving behind only ghostly black holes. None have been directly observed. Their existence remains an astronomical rumour whispered through equations. You drift farther, through expanding clouds of ionized gas. The colour, if you could name it, is every wavelength at once, a shimmer of blue-white brilliance. The stars cluster together, pulled by gravity, forming the earliest galaxies. They look fragile from here, like tiny whirlpools painted in light. You find yourself thinking of soap bubbles, except these bubbles weigh billions of solar masses and occasionally collide. Somewhere in the distance you glimpse a cluster collapsing inward, gas swirling like cream in coffee. That's gravity again, stubbornly sculpting the chaos. You can feel its pull in your chest, steady and ancient. Each atom knows its role, to gather, to fuse, to shine, to die. The universe doesn't yet understand life, but it already knows rhythm. Historians still argue whether consciousness could have arisen in any earlier cosmic epoch, if somehow awareness might exist without stars. The consensus says no. Without heavier elements, there's no chemistry complex enough for brains, for planets, for love songs. Hydrogen and helium alone make a bland menu. You can't bake bread without carbon, you can't write poetry without oxygen. So the universe, in its strange patience, begins with simplicity. It will take billions of years before it learns to dream through creatures like you. You pass near a star just forming, its surface a molten blur of fury. It roars, flinging plasma arcs taller than mountains. Inside, fusion hums like a perfectly tuned engine. The heat is unbearable, yet mesmerizing. You watch the light spill outward, photons bouncing through the dense interior for hundreds of thousands of years before finally escaping into open space. That same light may one day bounce off ocean waves or glance off a lover's eyes. It's oddly comforting, this thought, that even chaos has purpose given enough time. A piece of trivia drifts by with the cosmic dust. The hydrogen in every drop of water on Earth is older than any galaxy. When you sip from a glass, you're drinking remnants of that first burst of creation. Not bad for something that started as random quantum foam. As you float onward, the stars multiply. Each new light feels like a heartbeat, a reassurance that the universe is awake now, alive in a way it never was before. The silence between them hums with possibility. Somewhere hidden among all this radiant youth, the blueprint for carbon already waits, folded neatly inside the physics of fusion. You can't see it yet, but soon, very soon, stars will begin crafting the ingredients for everything that smells, breathes, and dreams. For now, though, you just drift. You let the warmth of starlight graze your face. You listen to the deep, slow pulse of the universe as it finds its rhythm. And you realize, even here, at the beginning of everything, you already belong. You hover near one of those early suns now, watching it breathe. Every few seconds, the surface ripples like the top of a boiling pot, shimmering arcs of plasma lashing out and curling back into itself. It's beautiful in a slightly, I hope that doesn't notice me sort of way. Inside, the real magic happens. Hydrogen atoms slamming together under pressures you can't imagine. When two protons fuse, they form deuterium, releasing energy as light and heat. That's the first breath of fusion, the quiet hum that keeps a star alive for billions of years. You can almost hear it, a slow, patient heartbeat echoing through the void. The universe feels young here. Everything is hotter, louder, brighter than it will ever be again. You can sense how fragile this balance is. Gravity pulling inward, radiation pushing outward. The star survives only because these two forces are perfectly matched. If gravity wins, collapse. If radiation wins, explosion. For now, though, the tension holds. A cosmic tightrope walk that defines existence itself. Historians still argue whether the first stars were truly gigantic. Some say hundreds of times the sun's mass. Others think smaller ones may have lingered longer, outliving their brilliant siblings. No one can prove it yet. Their light is too faint, too far gone, but the math suggests that size mattered. The larger the star, the faster it burned through its fuel. Imagine being so powerful that you burn out before you even get the chance to slow down. A bit like celebrity life, just with more plasma. You drift closer, feeling the tremor of fusion at work. 4 hydrogen nuclei combine through a series of steps to make one helium nucleus, releasing a small amount of mass as pure energy. Einstein's famous E equals mc2 hums softly in your head. It's not just a formula, it's the engine of the universe. The mass that disappears doesn't vanish, it becomes light, radiation, warmth. Every sunrise you've ever seen is a direct consequence of that quiet equation. A mainstream historical note flickers through your thoughts. When scientists on Earth first managed to recreate fusion reactions in hydrogen bombs, they realized they'd built miniature versions of stars. It was the ultimate paradox, understanding creation by studying destruction. The early Cold War scientists used to joke darkly that they'd found a way to make sunshine in a can. That grim humor feels oddly fitting out here. After all, stars themselves are nature's explosive reactors, just stable enough to be beautiful. You notice tiny ripples of light escaping the star's surface, waves that will travel across space for eons. Some will brush against dust clouds, heating them until they glow. Some will strike early planets, igniting atmospheres. And some, billions of years from now, will hit a retina, yours perhaps, and be perceived as a twinkle. It's strange how something so small can link you to an ancient furnace you'll never touch. Drifting a little farther out, you can see the space between stars shimmering faintly. This isn't empty. It's sprinkled with gas and particles, faint whispers of the material the stars shed. You realize you're watching the universe start to recycle itself. Matter formed from pure energy now gets reshaped into new patterns, preparing for whatever comes next. There's something oddly comforting about that. Even destruction here feels like preparation. A quirky tidbit pops into your mind. During fusion, stars generate not only light but neutrinos, tiny ghost-like particles that barely interact with anything. Right now, billions of them are passing through your body every second, even back home on Earth. You can't feel them, you can't stop them, but they're there, like invisible reminders that the stars never stop touching you. Somewhere, a poet might call that romantic. A physicist would just call it standard particle physics. As you watch the star breathe and shine, you begin to sense how fusion is more than a reaction. It's a rhythm. The core pulses gently, keeping time with cosmic expansion. It's as if the universe is a grand orchestra, and every star adds its own subtle note. Hydrogen to helium, the first chord. In a few million years, this star will shift keys, fusing helium into carbon. But not yet. Right now, it just sings in hydrogen. Historians still argue whether fusion began exactly as current models describe, or whether unknown quantum effects nudged the process along. It's one of those eternal debates that makes science so strangely human. No matter how much we learn, there's always a little mystery left to keep us humble. Some even suggest that the first fusion reactions may have started sooner, within dense pockets of gas that never quite became full stars. Unproven, of course, but fun to imagine. Little flickers of light hidden in the fog, precursors to suns. You let yourself float away from the furnace. Behind you, light streams outward in every direction. Ahead, the dark still stretches forever. It's easy to forget how large really is, until you see it from here. A star like this can shine for 10 billion years, yet it's still just one spark in an ocean. The universe doesn't rush. It has patience, a kind you can feel pressing against your skin. The star hums quietly to itself. You can almost imagine it whispering more time, more fusion, more becoming. You sense the helium ash building up in its core, a slow accumulation that will one day change everything. The light from this moment will keep travelling long after the star itself is gone, lighting up planets and nebulae in the eyes of curious humans. That's the beautiful irony. Even when a star dies, its light lives on. Somewhere deep within the furnace, a helium atom is born, pure and glowing. It's simple, unassuming, but it's the universe's first real act of transformation. Hydrogen became something new. Change, it seems, is written into the fabric of everything. You can't help smiling at the thought. Stars don't just exist, they evolve. Maybe that's the secret they've been keeping all along. You turn slowly, watching the cosmos expand around you. The darkness feels softer now, less like absence and more like space for possibility. You sense that this is only the beginning, that soon stars will start building heavier elements, stepping up their craft in a grand cosmic workshop. But for now, you just float there in the warmth of fusion's first breath, feeling your atoms hum in sympathy with the fire that made them. You ease closer to another star, a little older, a little wiser, its light steadier and more golden. The airless dark around it feels thicker somehow, as if time itself has learned to settle. You drift down through its glowing layers, past the turbulent surface where convection currents rise and fall like slow-motion tsunamis. Beneath that luminous ocean lies the beating heart of the star, the furnace that keeps the universe alight. Down here, everything moves in silence except for the pulse of fusion, a soundless roar that rattles your very atoms. You pass through a cloud of plasma so dense it's like you're wading through honey made of lightning. Every proton, every electron dances in a feverish blur. When two protons collide, they fuse, forming deuterium, a rare isotope of hydrogen. And in that instant, a photon is born. It takes hundreds of thousands of years for that single photon to escape the star's core, bouncing and scattering in a drunken zigzag until it finally breaks free at the surface. Only then does it shoot out into space, maybe to find its way to someone's window on some quiet night. You think of that the next time you look up at the sky. Every beam of starlight is ancient, a survivor of 1,000,000 collisions and a journey that would make even your phone's GPS cry. Here in the stellar core, the temperature reaches 15 million degrees Celsius. Pressure, about 200 billion times what you'd feel standing at the bottom of the Pacific Ocean. You wouldn't last a millisecond, but it's oddly comforting to know that if you could, you'd be glowing too. Stars are basically the universe's version of slow cooking, except the oven is gravity, and the recipe takes a few billion years. You pause, listening to the star's rhythm. Gravity squeezes inward, fusion pushes outward. Perfect balance. If either side falters, everything collapses or blows apart. You realize that this tension is universal. It's not just physics, it's a metaphor. You two are always balancing pressures. Work and rest, chaos and calm, hunger and satisfaction. Maybe the stars understand you more than you think. A mainstream historical fact drifts in. The concept of stellar fusion wasn't confirmed until the 20th century. Before that, scientists puzzled over how the sun could keep shining. Chemical burning, they thought, but that couldn't last billions of years. Then came the breakthrough. Hans Bethe in the 1930s explaining the proton-proton chain and the CNO cycle, showing that stars are nuclear reactors long before humans ever thought to build one. Somewhere out there, Beth is probably smiling at the irony. The universe solved energy production billions of years before we did. As you drift deeper, you sense how delicate this balance truly is. Every reaction, every collision, must happen just so. Too hot, and fusion races uncontrollably. Too cold, and it stalls. The star walks this narrow line perfectly, generation after generation of particles keeping time. You can't help but marvel at the precision, chaos wrapped in elegance. A quirky little fact flickers through your mind. Deep inside the sun, neutrinos are created during fusion, and some of them stream out almost instantly, passing straight through entire planets as if they were ghosts. Billions pass through your body every second, silent, unstoppable. The thought gives you a shiver, though technically, shivering would be impossible here. There's no air to carry the chill. Historians still argue whether the balance between gravity and radiation pressure is truly stable or a fragile coincidence. Some claim it's a self-regulating system that could last forever. Others insist every star is living on borrowed time. Either way, the lesson's the same. Even the brightest lights have limits. You hover now near the edge of the core, where helium ash begins to build up like sediment at the bottom of an ancient river. The star doesn't yet know it's making a future for you, it just burns, unaware of what its work will one day become. Still, you can feel it. The carbon atoms waiting to be born, the oxygen that will fill human lungs, the iron that will beat in your blood. You're watching destiny in real time. Above, convection currents churn like slow whirlpools, carrying heat outward and fresh hydrogen inward. The star breathes through these movements. It's strange, something so vast yet so alive. You trace a bubble of plasma rising to the surface, bursting into a brilliant flare, then fading into the black. Every flare that bursts out of a star, you think, is a kind of heartbeat, its own way of saying, I'm still here. A brief flash catches your eye, a solar prominence curling outward like a glowing ribbon. If you squint, you could almost mistake it for a cosmic dance, slow but graceful. You half expect it to hum a tune, maybe something soft and sleepy, because even the universe knows lullabies. The star continues its steady hum, fusion keeping it alive with quiet efficiency. You realize that this process, hydrogen turning to helium, is the most important act of energy making in the cosmos. Without it, galaxies would remain dark, planets would stay cold, and you would never exist to ponder any of this. The heartbeat of a star is, in a way, the heartbeat of life itself. You imagine what it would feel like to stand within that core, if such a thing were possible. Every atom of your being vibrating in perfect sync with the nuclear rhythm, every thought turned into light. For a moment, you almost understand the appeal of immortality. Stars don't worry about Mondays. They just burn steadily, beautifully, until they can't. When you finally pull back, rising through layers of gas and heat, the surface roils below like liquid gold. The edges shimmer where light escapes into space, each photon carrying a whisper of the core's secret. You take one last look into that luminous eye and think, so this is how creation feels from the inside. You drift outward again into the calm between stars. Behind you, the light fades to a distant gleam, but the pulse of fusion lingers in your chest. The universe feels vast and oddly intimate at the same time. You realize that even though you're made of atoms that were once part of stars like this, you'll never quite stop yearning for that warmth, the place where you began. The star you've been watching exhales, and you drift with the light it releases, upward, outward, beyond the yellow shimmer of its surface until you're floating above a red giant. It's older now, puffed up and weary but strangely dignified, like an actor who's been playing the same role for billions of years and finally knows every line by heart. Inside, something profound has begun. Helium burning. You can feel the shift, the new rhythm pulsing through its core. Fusion is no longer the quiet simplicity of hydrogen to helium. This is heavier work, slower, more deliberate. The star is crafting carbon and oxygen, the two elements that will later sculpt everything familiar about you. Your breath, your bones, your favourite cup of coffee. You ease closer, watching the outer layers ripple in long, lazy waves. The star's body expands with every fusion cycle, glowing orange and swollen. You can practically see gravity and pressure arguing. Gravity pulling in, radiation insisting on pushing out. For now, they compromise, and the star continues to shine. But you can tell it's tiring. The calm, efficient hum of youth is gone. This is the deep, crackling breath of old age. Inside the core, helium nuclei collide at impossible speeds, fusing into carbon through what astrophysicists call the triple alpha process. 3 helium atoms, 3 alpha particles, combine to make one carbon nucleus. Sometimes, if the heat rises high enough, a 4th helium joins the party, creating oxygen. The result is breathtaking. Elements that didn't exist before now swirl in the heart of the star, like a recipe that's just learned to add flavour. You watch it happen and realise you're witnessing cosmic alchemy. Historians still argue whether the first red giants formed in the universe's earliest galaxies or later, once the stellar population had matured. Either way, this is where complexity truly begins. Every heavy atom owes its life to the crucible of a dying star. There's something poetic about that. Beauty born of exhaustion, creation hidden in collapse. You slip through a layer of fiery gas that smells, not that you could smell out here, like the metallic tang of ozone. The light flickers in soft waves, more orange than gold. The star pulses, growing slightly dimmer, then brighter again, like it's breathing in slow motion. You drift deeper into its atmosphere, and the sensation is strangely hypnotic. You can almost hear its sigh. A mainstream historical fact pops into your thoughts. The carbon-oxygen fusion process wasn't confirmed until the mid-20th century, thanks to the work of astronomers like Fred Hoyle. He proposed that an unexpected resonance in the carbon nucleus made the triple alpha process possible. Without it, carbon-based life would never have existed. It's one of those eerie coincidences that make scientists and philosophers equally uncomfortable. Why should the universe's laws be so perfectly tuned to create life? Hoyle himself found the thought unsettling, muttering that it felt as if some super-calculating intellect had designed the physics to favour our existence. Whether you call that divine planning or lucky math, it makes you blink a little slower, feeling small in a good way. A quirky little detail floats through your head. When the sun eventually becomes a red giant about 5 billion years from now, its outer layers will expand past Earth's current orbit, so technically our planet will be swallowed whole. Don't panic though. You'll have long since relocated to another world or maybe turned into stardust again. It's oddly comforting to know that the same process that destroys worlds also creates them. You look back at the red giant's surface. Massive plumes of gas drift off like lazy smoke rings, forming a halo of shimmering dust. This dust, glowing faintly in the star's light, is the universe's most precious export. It will travel across space, seed new nebulae, and one day, billions of years later, become the carbon in trees, the calcium in shells, the oxygen in your lungs. The star is dying, but its death is an act of generosity. Historians still argue whether the rhythmic pulsing of red giants is purely a physical phenomenon, or if some internal quantum feedback amplifies it. Some stars seem to brighten and dim like clockwork. Others stutter irregularly, as if struggling to remember their lines. Either way, the light show is mesmerizing. You find yourself drifting in sync with the beat. Bright, dim, bright again, each pulse echoing softly in your chest. the star's outer layers begin to shiver, and a thin wind of particles flows outward. You can see it forming a faint mist, helium, carbon, oxygen, all slowly leaking into space. To you, it looks like glitter spilling from a broken ornament. To the universe, it's the beginning of something new. This gentle shedding will eventually form a nebula, a glowing cloud that might cradle future stars. Every dying breath here becomes a promise whispered into the dark. A sudden flare catches your eye, a flash brighter than anything yet. The core has reached another threshold. The temperature spikes, and for a moment, you sense the immense struggle taking place inside. The star is forging new elements, but it's also teetering on instability. Gravity's grip tightens, fusion pushes harder, and the cycle accelerates. You can almost feel the tension like a high note sustained too long. The colour around you shifts toward crimson. The light softens, thickens, spreading across space like watercolour in water. You drift backwards now, giving the star its space. You can't help thinking of it as an artist nearing the end of a masterpiece. Exhausted, glowing, utterly magnificent. Its final act is to leave something beautiful behind. Somewhere far beyond this scene, a tiny planet circles a smaller star, still young, still quiet. On that world, future creatures will one day look up and wonder where their atoms came from. You already know. You watch them being born in the breath of this red giant. You know that life is just starlight slowed down and rearranged. As the star dims slightly, you feel the universe exhale with it. Everything cools, just a little. The rhythm slows, the darkness presses in again, but it feels different now, fuller, more meaningful. You realize that even in its aging, the star has not failed. It has only changed purpose, it no longer shines for itself, but for what comes next. You drift back through the dust, feeling it brush past you like warm sand in a cosmic breeze. Somewhere in that glowing haze, carbon atoms are waiting, destined to become something astonishing. You smile, because you already know how that story ends. You drift through the haze left behind by the red giant, a vast, glowing cloud that looks like the ghost of a star still clinging to the night. The light is dimmer here, softer, and the silence feels heavier, like you've stepped into the pause between one breath and the next. But in that quiet, the universe is busy. The alchemy ladder, the grand cosmic sequence of element making, continues to climb. You're watching the periodic table build itself rung by rung, one fusion reaction at a time. Below you, the dying star's core has contracted into something fierce. A white-hot sphere of carbon and oxygen, dense enough that a teaspoon of it would outweigh an elephant. It's not burning anymore. It's glowing from residual heat, like the last coal at the bottom of a dying fire. But elsewhere, in larger stars still alive and raging, the process continues. You turn toward one such behemoth. Its light sharp and blue, its surface rippling like the skin of an ocean made entirely of fire. Inside, it's hard at work climbing that alchemy ladder. Hydrogen to helium, helium to carbon and oxygen, you already know those steps. But in the hearts of massive stars, the reactions go further. Carbon fuses into neon, neon into magnesium, magnesium into silicon, and silicon into iron. Each stage demands higher temperatures, more pressure, more courage. You can almost imagine the atoms grimacing as they collide, refusing to yield until the heat becomes unbearable. The ladder grows steeper with every rung, each step shorter-lived than the last. A small star like the Sun can spend billions of years burning hydrogen. A massive star burns through all its stages in just a few million. The bigger you are, the faster you live, the harder you fall. A historical fact glows faintly in your thoughts. Scientists first mapped this fusion sequence in the mid-20th century, calling it stellar nucleosynthesis. It was one of the most profound discoveries in astrophysics, the realization that every element heavier than helium came from stars. Before that, even great minds like Newton and Darwin never knew that iron and gold and oxygen were born in fire. The universe, it turns out, is a blacksmith. You drift into the outer shell of the massive star, watching the layers shimmer in nested colours. Each layer burns a different fuel, hydrogen in one, helium in another, carbon deeper still. It's like peeling back the layers of a cosmic onion, except this onion's 10 million degrees and hums with the sound of atoms dying. You can almost hear the music of it, each shell playing its own rhythm, all of them building towards something phenomenal and dramatic. Historians still argue whether this layering happens cleanly or chaotically. The equations say it should be neat, but the evidence, supernova remnants, spectral readings, suggests turbulence, mixing, rebellion. Stars, it seems, don't follow the rules perfectly. They're artists as much as engineers, their creations laced with improvisation. Somewhere in this burning labyrinth, an element forms that wasn't supposed to. And because of that tiny accident, maybe someday a planet will breathe. A quirky fact surfaces as you float near the silicon-burning core. This phase, the very last before a star's collapse, lasts only about a single day. A star can spend millions of years fusing lighter elements, then rush through its final transformation in less than 24 hours. It's the most dramatic kind of burnout imaginable, cosmic sprint towards self-destruction. You can't help but respect the dedication. You glide closer, through the blistering brilliance. The deeper you go, the heavier the elements, the faster the rhythm. It feels like standing inside the gears of a clock wound too tight. Every reaction is both creation and farewell, every burst of fusion a whisper that says, soon. The universe has a habit of turning endings into beginnings, and you're watching it rehearse that truth in real time. Gravity keeps pushing inward. The nuclear furnace keeps pushing outward. You've seen this balance before, but now you sense that it's slipping. The core grows heavier with iron, an element that marks the end of the fusion ladder. Iron doesn't yield energy when it fuses, it consumes it. When a star reaches iron, the alchemy halts. There are no more rungs to climb. You can feel that truth settle in your chest like a held breath. Historians still argue whether the transition from fusion to collapse happens instantly or gradually. Some models suggest the core buckles in milliseconds. Others think it hesitates, trembling at the edge before the fall. Either way, the star's fate is sealed. You can almost feel the tension crackle, as though the entire cosmos is waiting for the next act. You pull back from the core, your vision filling with the enormous glow of the outer layers. They still blaze with hydrogen and helium fusion, unaware of what's coming. The whole structure looks stable from out here, serene even, but you know the truth. Deep inside, the iron heart is forming, dense and cold, a silent weight that will soon bring everything down. A flare ripples across the surface, and for a moment the star looks alive with colour. Violet, gold, blue. You could almost believe it's celebrating its own brilliance, throwing one last cosmic party before gravity cuts the lights. You smile, because even here there's humour. The universe is old, but it still enjoys a little drama. You think about the ladder itself, the logic of it, the elegance. From hydrogen to iron, each element building upon the last. You wonder if there's a metaphor hidden in that progression. Maybe every act of creation, no matter how bright, eventually hits its limit. Maybe even stars have to let go of control before they can truly transform. The light around you flickers as the star's pulse quickens. You can feel the climb nearing its end the moment before the leap. Soon the star will cross the final threshold, and the calm furnace will become a storm. But not yet. For one heartbeat longer, the alchemy continues, hydrogen whispering to helium, helium singing to carbon, carbon bowing to oxygen, all of them harmonizing in the grandest, most patient choir the universe has ever known. And then, silence again, the stillness before collapse. You float there, weightless, the echoes of fusion humming in your bones, and you realize that every heartbeat on Earth is a quiet reflection of this same cosmic rhythm, a steady, burning desire to keep existing just a little longer. The silence after the fusion stops feels like standing in a cathedral after the choir has finished singing. The air, or what passes for air out here, is still humming from the last note. You hover in that pause just outside the massive blue star, and sense that something is breaking inside it. The alchemy ladder has ended. The core, filled with iron, can no longer produce energy. It's as if the star's heart has turned to stone. Gravity, patient and pitiless, begins to win. You drift closer, feeling the immense pressure tightening like a clenched fist. The outer layers still blaze with fusion, unaware of what's happening below, but in the core, atoms collapse, electrons are squeezed into protons, forming neutrons, and the core shrinks at 1/4 the speed of light. Imagine an entire sun crammed into the size of a small city. It's almost too much to hold in your mind. The temperature spikes to billions of degrees, and yet, paradoxically, there's a sense of stillness, like the split second before thunder. A historical fact surfaces in your thoughts. It was in the 1930s that physicists realized iron marked the end of stellar fusion. The discovery came from studying nuclear binding energy, how tightly atomic nuclei hold themselves together. Fusing lighter elements releases energy, fusing iron consumes it. The universe, it seems, is thrifty with its fire. Past this point, stars can only collapse or explode. You can feel both possibilities simmering in the star's bones. You can almost hear the groan of its structure bending inward. Layers upon layers crash down onto the inert iron heart. The pressure mounts until the core's collapse halts abruptly, so abruptly that it sends a shockwave racing outward faster than imagination. In that instant, the quiet ends. The universe opens its throat and screams. This is the iron wall, the end of fusion, the beginning of chaos. You can't help but flinch, even though nothing out here can touch you. The shockwave rips through the star's outer layers, igniting them in a burst brighter than galaxies. For a few heartbeats, it's as if 1,000 suns have been lit in one place. You think of fireworks, if fireworks could rearrange the elements of reality. Historians still argue whether the collapse happens purely through gravitational rebound or if neutrinos, the ghost particles you met earlier, play a bigger role. Some models suggest those elusive messengers flood the collapsing core, adding the extra push needed to blow the star apart. Others insist gravity alone is enough. Either way, the star doesn't care. It's already in the middle of its death cry, and the sound of it, if you could hear it, would flatten mountains. You drift through the expanding shockwave, particles streaming past like molten snow, hydrogen, helium, carbon, all ripped from their stable shells and hurled into the void. Iron shatters, scattering fragments that will someday fuse again under different stars. The blast is both destruction and rebirth, the universe's favourite paradox. You can taste the radiation like static on your tongue, a bright metallic flavour of pure energy. A quirky tidbit flashes through your thoughts. When a star hits this point, the resulting supernova can briefly outshine its entire galaxy. For a few days, that single dying star becomes the most luminous object in millions of light years. Ancient civilizations actually witnessed some of these explosions. The Chinese recorded one in 1054 CE, the supernova that created the Crab Nebula, and their astronomers described it as a guest star that shone even in daylight. You can almost imagine them staring up, unaware they were watching the birth of cosmic iron for the future blood of humanity. The explosion slows, and you glide toward the remnant, the collapsed core that's left behind. It's impossibly dense, made almost entirely of neutrons, a city-sized sphere with more mass than the sun. Light bends around it, time stretches near it, and if you listen closely enough, you might almost hear it spinning, a millisecond pulse of pure gravity. This is the heart that remains when the fire runs out. You feel a strange kind of respect for it. Even in death, the star refuses to be small. Historians still argue about what exactly happens in the microseconds after the collapse. Does the core bounce instantly? Does the shockwave stall and then reignite? The equations are maddeningly complex. Supercomputers run simulations that crash more often than they finish. It's humbling to realize that even now, in the age of exoplanets and quantum tunneling, the precise mechanics of a dying star are still a mystery. The universe likes to keep some secrets, it seems, just enough to make you keep looking up. You glance back at the fading explosion. The outer layers are already cooling, spreading into glowing clouds that will become nebulae. In those clouds, new elements swirl. Nickel, cobalt, silver, gold, and the star couldn't make them through fusion, but in its death throes it forced them into existence. You're surrounded by freshly minted matter, some of which will one day sparkle in a ring, or glint from a scalpel, or pulse inside a bloodstream. The cosmos wastes nothing. The light around you dims to a deep orange. The expanding shell of debris stretches out like a slow-motion firework. Somewhere in that storm, a neutron star spins, whispering to the universe with each rotation. You can't hear it, but you can feel its rhythm, fast, steady, relentless. It's almost comforting, like a cosmic metronome keeping time in the silence that follows the blast. You realize that every iron atom in your blood once hit this wall. Every bit of oxygen you breathe once rode a shockwave like this. The same physics that tears stars apart also holds your molecules together. You're not just watching history, you're made of oil. The glow fades as the remnants drift outward, scattering through space like glitter spilled from a broken ornament. You drift with them, weightless and quiet. And for the first time tonight, you feel the vastness of the universe settle around you. Not empty, but full of promise. Stars die, yes. But the story doesn't end at the Iron Wall. It's only pausing, catching its breath before the next act begins. The blast hasn't finished speaking yet. You're still floating in the aftershock where light is thicker than thought and time feels stretched, syrup slow. The star that hit the Iron Wall has fully erupted into a supernova symphony. Every note a wave of raw energy roaring through the dark. You can't tell whether you're hearing it or feeling it. The vibration passes straight through whatever counts as your body here. The explosion is a painter, and space its canvas, fiery petals of red and gold blooming outward faster than anything you could blink at. Inside the storm, chaos becomes art. The temperature spikes to 100 billion degrees, and nuclei smash together in a frenzy of fusion far beyond what a peaceful star could ever manage. Gold, silver, uranium, and other heavy metals are hammered into existence in mere fractions of a second. You realize you're watching creation at its wildest, the universe conducting a concert of violence and beauty, an orchestra made of fire. The shockwave keeps expanding, sweeping up gas and dust as it goes. Everything that once belonged neatly to the star, its hydrogen, its carbon, its stautry, is scattered. You follow a streak of glowing debris as it spins outward, tumbling like a meteor without a world. It will cool, drift, join a nebula someday, maybe even seed a new solar system. The phrase ashes to ashes never sounded so literal. A mainstream historical fact flickers through your thoughts. The first supernova ever studied with telescopes occurred in 1604, when Johannes Kepler chronicled a new star that burned in the constellation of Fucus. He didn't know it was a dying sun. No one did. Centuries later, astronomers named it Kepler's star, the light of a star's death travelling 20,000 years just so it could whisper to human eyes. There's a strange comfort in that, how even destruction can take its time to arrive. You drift deeper into the maelstrom, where particles rush like a river in reverse, falling outward instead of inward. The colours here are indescribable. Plasma blues melting into copper, then fading to a bruised violet. The dust itself glows, infused with radiation. You reach out instinctively, though your hand is only an idea here, and the particles slip through you, each one carrying a story millions of years long. Historians still argue whether every heavy element comes solely from these explosions, or if neutron-star collisions share the credit. Some say supernovae alone forged the universe's gold, others insist the math doesn't add up. Either way, you're standing in the middle of evidence, clouds of newborn metal so fine they shimmer like smoke in candlelight. If jewellery stores had a smell, this would be it. Ozone, heat, and the faint sting of new beginnings. A quirky tidbit crosses your mind. When a supernova erupts close enough, it can trigger new star formation in neighbouring clouds. One death jumpstarts dozens of births. The universe has an odd sense of recycling. You imagine stars gossiping across the void, one shouting, "I'm out," while dozens reply, "Thanks for the materials." Somewhere future suns are already gathering in the glow of this very blast. The expanding shell keeps growing, pushing against interstellar gas like the crest of a wave. Inside the shock front, radiation ionizes atoms, making them fluoresce. You're surrounded by light that moves as slowly as thought, curling in filaments and threads. It's hypnotic. You let yourself drift through it, watching it thin, stretch, and finally fade into transparency. The core's remnants glimmer in the center, shrinking into something small and terrifying, a neutron star, dense enough that a teaspoon of it would outweigh a mountain. It spins furiously, spitting out beams of radiation like twin searchlights. For a moment you imagine that beam sweeping across Earth millions of years from now, flickering faintly through telescopes. Someone will measure it, name it, maybe even write a song about it. They'll never know you were here to see its first turn. A mainstream aside hums in your ear. The supernova that created the Crab Nebula in 1054 CE was bright enough to cast shadows at night. Monks in Europe wrote of a star that mocked the moon. Somewhere in China, astronomers tracked its position every night for almost 2 years. Those records still guide modern astrophysicists, proving that ancient eyes saw the same violence you're floating through now. The shock front passes you, slowing. Behind it, space begins to cool, the roar of radiation fading into whispers. The debris thins into dust. You can almost sense molecules forming again. Carbon monoxide, water, silicates, the first chemistry of a future planet. The heat eases, and you drift backward through the glowing cloud like swimming through the remnants of a firework long after the sound is gone. Historians still argue whether the universe's earliest generations of stars could explode this way at all. Some theories suggest they were too massive, collapsing directly into black holes instead of bursting. Others imagine they went off with such violence that entire proto-galaxies were sterilized. Either way, supernovae mark the universe's shift from simplicity to complexity, from hydrogen to hope. You watch the last filaments of the explosion twist into lace against the darkness. The center dims, a fading ember at the heart of the nebula. The silence returns, not the dead kind, but a fertile quiet, full of possibilities. You can almost hear the faint hum of atoms cooling, of gravity planning its next move. The debris you're floating through will travel for billions of years, cross light centuries of emptiness, and someday, in some quiet corner of a spiral galaxy, gather again. Maybe it will become soil under someone's feet, or calcium in a seashell, or laughter in a kitchen. Right now it's just dust, but you know better. Dust is how the universe remembers. The last pulse of light from the dying star reaches you, a faint wave of warmth that feels oddly like gratitude. You close your eyes, not that you need to, and drift with it, letting the glow fade into darkness. Somewhere ahead, new stars are waiting to be born. You're still adrift in the cooling afterglow of the explosion, the faint shimmer of dust swirling like powdered sunlight around you. It's quieter now, less of a roar and more of a sigh, the long exhale of a universe that just performed one of its greatest tricks. As the last waves of energy fade, what remains is astonishingly delicate. Billions of microscopic grains glinting faintly, drifting in slow spirals. You're floating in the birthplace of everything solid, and if you could cup your hands, you'd be holding the building blocks of rings, rocks, and living things. Somewhere inside that glowing haze lies gold, literal gold. Freshly forged atoms, created just seconds before in the shockwave of the supernova. You reach toward them, and though you can't touch, you can imagine the weight of it. Dense, beautiful, rare. It's hard not to laugh when you realize how much violence it took to make something so gentle and decorative. The bracelet on someone's wrist, the circuitry in a computer, the fillings in a tooth, all of it was once molten metal flung across galaxies. Stardust, with delusions of grandeur. You follow one golden particle as it drifts through the debris. It tumbles slowly, colliding now and then with flecks of silver, platinum, and iron. Some will clump together over eons, some will travel alone. The star's death has scattered its body across light years, and yet it's not gone. It's everywhere. You feel a kind of intimacy in that, a reminder that endings here are never truly endings. A mainstream historical fact floats into your thoughts. When scientists examined the spectral lines of sunlight in the 19th century, they discovered traces of metals forged in ancient stars. Every atom heavier than helium had to come from some stellar catastrophe. Later in the mid-20th century, astronomers like Margaret Burbidge and her colleagues formalized this understanding in the landmark paper B2FH, explaining how stars build elements up to iron and beyond through supernovae. That paper remains one of the cornerstones of astrophysics, a quiet reminder that your wedding ring and your skeleton share an origin story. The supernova's heart still flickers behind you, a faint, pulsing light that could be a neutron star or, if fate was a little crueler, a newborn black hole. You can't quite tell yet, but here among the cooling clouds the temperature drops enough for dust to solidify. Silicates form crystalline webs, carbon condenses into soot. You drift through this new snowfall of atoms, realizing that every grain is a tiny archive of chemistry, a letter from the universe written in metallic ink. Historians still argue whether supernovae alone can account for the abundance of heavy elements like gold and platinum. Increasing evidence points toward another source, neutron star mergers, but the debate continues. For now, you're standing in the middle of proof that at least some of it comes from these explosions. You can feel it in the glittering cloud that clings to your perception like fog. It's breathtaking, and also just a bit absurd. Entire civilizations might one day fight over the dust you're watching drift by. A quirky tidbit crosses your mind. In 2017, astronomers observed gravitational waves from a neutron star collision for the first time, and the light that followed revealed gold being created in real time, enough to outweigh Earth several times over. Humanity's reaction? A mix of awe, confusion, and the immediate question, so, could we mine it? You can almost hear the stars chuckle. The cloud you're in begins to stretch, tugged by gravity from nearby regions of space. It's the early whisper of structure, clumps forming inside chaos. Each cluster of dust will one day become part of something larger. You can see faint ribbons curling where magnetic fields guide the motion, shaping beauty from randomness. It feels alive, this process, though it's not life yet. It's just the patient persistence of physics pretending to be poetry. You drift past a denser patch where the light dims slightly. Here, atoms cling to one another, forming chains and clusters. Carbon bonds with oxygen to make carbon monoxide, silicon links with oxygen to form quartz-like dust. It's chemistry's debut performance, the first choreography of atoms learning how to hold hands. You wonder if, in some infinitesimal way, this is the ancestor of affection, the universe's first experiment in connection. Historians still argue whether life could have started differently, without carbon, without oxygen, but so far these elements remain the stars of the show. You look at the swirling dust and think, this is the prologue to everything that breathes. You can almost see the faint outline of what will come, planets, oceans, cells, but right now, it's all potential, folded neatly into glowing powder. A soft wind of radiation brushes through the cloud, stirring it gently. You catch glimpses of different metals reflecting light. Copper with its warm gleam, silver flashing, cool and sharp, iron pulsing a deep orange. They look like confetti after a festival. You smile at the absurdity of it all, the cosmos throwing a party that no one's around to see, celebrating the creation of atoms that will someday worry about taxes and first impressions. You pass a small clump of dust that's just starting to spin. Gravity, subtle and persistent, is pulling it together. It's barely a whisper of a future star, but already the motion hints at destiny. You can sense the cycle restarting. Every element forged in the explosion will find new purpose. Every scattered atom will return to heat and light again. The universe apparently doesn't believe in waste. As the glow fades and the cloud begins to thin, you turn once more toward the faint pulse of the neutron star behind you. It's steady, calm now, as if proud of what it has created. You realize that in this moment, surrounded by gold dust and carbon soot, you're standing in the middle of everything that will ever be. Your body, your planet, your breath, they all begin here, in the ruins of a dying sun that refused to fade quietly. The silence deepens, the dust drifts. You let it brush against your face like soft snow and whisper a quiet thanks to the stars, to the physics, to the improbable fact that chaos can lead to beauty. Somewhere, far away, new lights are already flickering to life. You turn toward them, at these two, to follow. You follow the shimmer until the gold dust gives way to something denser, darker, a rippling field of gravity so strong that even light seems to hesitate before passing through. You've drifted into the neighborhood of two neutron stars, each no larger than a city but heavier than the sun, locked in a desperate orbit around each other. They circle faster and faster, spiraling together in a ballet of doom that looks oddly elegant from here. You can feel their pull in your chest, a deep thrumming rhythm that makes your thoughts vibrate. Every turn brings them closer, every heartbeat tighter, until you realize that you're watching another kind of forge, a neutron star forge, where the universe's most precious metals are minted in the blink of an eye. The first time they pass close enough, tidal forces tear at their crusts. Fragments of neutrons burst into space, flinging jets of matter at nearly the speed of light. When they finally collide, the explosion is quieter than a supernova, but stranger, an almost musical burst of light and gravitational waves that ripple through the fabric of reality itself. If you could hear them, the waves would sound like a deep, rising hum. Boom! The universe's bass note. A mainstream historical fact drifts through your thoughts. In August 2017, humanity actually caught one of these events. Astronomers detected both the gravitational waves and the light from two merging neutron stars in a galaxy 30 million light-years away. The event, G-Dum-1708 confirmed theories that these collisions create much of the gold, platinum, and other heavy elements in the universe. For days afterward, telescopes around the world turn toward that tiny patch of sky, watching the light fade as freshly forged metals cooled. Somewhere in those data points, the story of your jewellery, your coins, and even the wiring in your headphones began. The light here is haunting. It glows a pale blue-white at first, then fades to crimson as the debris expands. The blast isn't as large as a supernova, but its precision is astonishing. You can see filaments of pure platinum twisting through the ejector, streams of gold curling like molten rivers, uranium glimmering faintly like green glass. If you could breathe, it would smell metallic, sharp, cold, and ancient. You drift through the cloud feeling both awed and slightly absurd. You are, after all, floating through a priceless fortune no one will ever spend. Historians still argue whether these mergers or supernovae contribute more to the universe's stash of heavy elements. Some models favour the supernovae, others suggest neutron star collisions dominate. The truth might be a mix, which feels fitting. Creation rarely picks favourites. You can almost hear the physicists arguing in some faraway conference room, surrounded by coffee cups and half-erased equations, while the cosmos calmly does its work right here, elegantly and wordlessly. You watch as the expanding debris cools, radiation fades, and the newly minted metals start to condense into tiny solid grains. It's mesmerising, like watching frost form on glass, except the frost is made of gold atoms arranging themselves into perfect crystalline lattices. They'll drift through space now, part of the great interstellar soup, waiting to be swept up by gravity into new stars, planets, maybe even civilizations. It's strange to realise that what you're watching right now could someday rest in someone's pocket, or on a monarch's head, or inside the circuitry of a spacecraft. The universe, it seems, loves to give souvenirs. A quirky tidbit flashes across your thoughts. Neutron stars are so dense that a single teaspoon of their matter would weigh about 1 billion tons. If you could scoop some and bring it home, it would sink straight through Earth's crust and probably keep going. You can't help but laugh quietly at the thought. Space is a great reminder that you should never take anything too literally. The light dims and you see what remains of the collision. A faintly glowing remnant. Maybe a heavier neutron star, or maybe, if it was just massive enough, a newborn black hole. Around it, a thin disk of matter swirls, heated by friction until it shines again. You drift along the outer rim, feeling time distort slightly, the same seconds stretching longer, slower, as you near the edge of gravity's appetite. Historians still argue about the exact boundary, how dense, how massive, how fast two neutron stars must collide to form a black hole instead of merging peacefully. It's one of those delightful uncertainties that keep graduate students awake at night. You smile, imagining someone on Earth right now looking at data from this very kind of event, not realizing you're hovering here watching it live. You tilt your head back, if a head still exists, and watch the expanding clouds spread into the dark. The colours fade into a soft violet mist. The stars around you blink through it, their light bending slightly as it passes near the lingering gravity. Everything feels suspended, fragile, and impossibly quiet. You find yourself whispering to no one in particular, so this is where gold comes from. It's funny, in a cosmic sort of way. People on Earth spend lifetimes digging, melting, weighing, and polishing this metal as if it were the rarest thing imaginable. Yet here it floats in rivers, spread across light years, gleaming softly under alien suns. You imagine a cosmic jeweler polishing the universe, one collision at a time. Maybe that's the secret. Beauty born from catastrophe, shining quietly long after the noise has faded. You let yourself drift with the expanding debris for a while longer. The gravitational hum fades, replaced by the faint whisper of radiation. The collision's afterglow becomes a fading ember, a cosmic bruise that will take millennia to heal, but the metals remain, scattered and stubborn, tiny reminders that even destruction has purpose. Somewhere behind you, another pair of neutron stars begins their slow waltz, their mutual gravity tugging them closer with every orbit. You can sense their rhythm echoing through the void, a promise that this will happen again and again, across galaxies, across epochs. The universe keeps its factories running. You glance down at your hands, or where they would be, and imagine them dusted in gold. You can't help but grin. "Nice try, Cosmos," you murmur, "but I'm not pawning these." The silence doesn't answer, but the faint glimmer of distant light feels like a wink. You let the last shimmer of gold dust fade behind you and turn toward the deepest dark. Ahead, gravity folds space like silk being gathered into a fist. Even light bends here, hesitant. Curling around something you can't quite see, you've reached the threshold of mystery itself, a black hole. It's not as dramatic as you expected. No whirlpool of chaos, no lightning crackling across the void. Just an absence so complete it gleams, a circle where stars vanish mid-glow. You edge closer, drawn by curiosity and a mild sense that this might be the worst possible idea you've ever had. Around the blackness spins an accretion disk, a radiant halo of gas stripped from nearby stars. It whirls at nearly the speed of light, friction heating it to millions of degrees. From a distance it looks calm, but up close it's a storm of falling matter, bright enough to outshine entire galaxies. Each particle screams as it dies, though space politely mutes the sound. You can feel the pull, subtle at first, then stronger, until your thoughts begin to stretch like taffy. It's not frightening exactly, just humbling. You've never felt gravity think about you before. A mainstream historical fact surfaces. The first image of a black hole's shadow captured by the Event Horizon Telescope in 2010 showed exactly this, a ring of fire encircling darkness. Scientists cried when they saw it. Decades of theory, simulations, and late-night math suddenly had a face. Humanity stared into the abyss, and for once the abyss looked photogenic. You glance at the ring now and realise that every pixel of that picture was an echo of this very physics. The same gravitational bending you can feel tugging at your edges. You hover just outside the event horizon, the invisible boundary where escape becomes impossible. Here, time slows. Seconds outside pass like centuries for you. Photons curve in endless spirals, trapped in orbits of light. The effect is dizzying. The stars behind you smear into streaks, and you realise you're watching time being painted. For a moment, you almost reach out, wanting to touch the curve of reality itself. Historians still argue whether black holes destroy information or store it in some twisted form on their surfaces. Hawking radiation, holographic principles, quantum weirdness, every idea battles for dominance. Somewhere back on Earth, physicists debate whether the universe is just one vast black hole-shaped memory. You drift here, listening to their echoes, and think, maybe every mystery is just the cosmos trying to keep a little privacy. A quirky tidbit flickers by near certain black holes, matter jets burst from the poles, narrow beams of particles shooting thousands of light years into space. They're so bright that telescopes can spot them halfway across the universe. No one's completely sure how something that can't let light escape somehow launches light outward, but the paradox is part of the charm. You watch one now, a pencil-thin stream of plasma carving through the dark like a cosmic laser pointer. If aliens are taking notes, this would be the universe's "you are here" sign. You inch closer, watching the accretion disk swirl faster. The colours blur from gold to violet to ultraviolet, a rainbow no human eye was built to see. Each particle falling inward compresses decades of energy into milliseconds. It's the most efficient engine in existence, matter turned into pure radiation with almost no waste. You feel the heat vibrate through the emptiness, the hum of energy older than galaxies. You wonder whether black holes help forge elements the way supernovae do. Historians still argue about that too. Some theorise that the extreme pressures near the event horizon might create exotic nuclei before swallowing them. Others think the environment is too chaotic for stable fusion. It's one of those ask the universe yourself questions, and here you are, trying exactly that. See, if black holes could speak, maybe they'd tell you that creation and destruction are the same thing, viewed from opposite sides of time. The gravity deepens, stretching light into red streaks. You can feel yourself being pulled toward the edge, but the disk's motion carries you safely along the outer rim. Below you, the horizon glows faintly, not from the hole itself, but from photons that almost escape and then fall back in, looping endlessly. They look like fireflies caught in orbit, tracing circles you'll never finish counting. A mainstream note surfaces in your thoughts. Cygnus X1, the first strong black hole candidate discovered in 1964, convinced most scientists these monsters were real. Before that, even Einstein doubted they could truly exist. You imagine his ghost somewhere, nodding slowly, muttering something about the universe having an inconvenient sense of humour. You glance up. Far beyond the spinning disk, the surrounding space sparkles with stars, some young and hot, some old and red, each one a potential donor to this hungry neighbour. Gravity, it seems, is the universe's most persuasive collector. You wonder how many suns have already fed this hole, how many more will join. And then a stranger thought slips in. Maybe in swallowing light, black holes help shape galaxies, regulating starbirth like cosmic gardeners pruning chaos. You float there mesmerized until time loses meaning. Minutes stretch, collapse, fold. Somewhere, perhaps billions of years away, galaxies merge and fade. But here, on the rim of this endless well, everything feels perfectly still. The disk hums softly, the jets flicker, and the blackness in the center waits, patient, absolute. You know you shouldn't, but curiosity wins. You lean closer, just enough to see the faintest reflection of yourself bending across the curve of space. For a heartbeat, you exist in two places, outside, watching, and inside, falling. Then you pull back, laughing quietly. Not tonight, you whisper. Maybe next universe. As you drift away, the black hole recedes into shadow, the jets fading to pinpricks. The stars ahead gleam brighter, grateful for your return. Behind you, the abyss keeps spinning, swallowing, singing softly in a key no human ear will ever hear. It's not evil, not hungry, just honest. A reminder that even light needs somewhere to rest. You leave the black hole behind, though part of you still feels its gravity tugging gently as if it was reluctant to let go. The darkness gives way to colour again, soft blues, misty violets, and faint threads of pink. You're floating through the quiet remains of an ancient supernova, a nebula. It stretches across light years, luminous and ghostly like the breath of a sleeping god. The air here, if you can call it that, shimmers with dust and ionized gas. It's the ashes of long-dead stars, slowly weaving themselves into something new. The universe has turned its tragedy into a nursery. You drift through the haze, and the light glows brighter where ultraviolet rays from nearby young stars strike the gas. Hydrogen turns to red, oxygen to green, sulfur to blue. You're inside a cosmic watercolor that paints itself anew every second. The quiet hum of radiation makes your thoughts slower, softer. This is where the cycle begins again, cosmic recycling centers, where everything that died becomes raw material for new life. A mainstream historical fact comes to mind. The Eagle Nebula's Pillars of Creation, captured by the Hubble Space Telescope in 1995, showed humanity its first clear glimpse of this process. Giant towers of gas and dust stretching for light years, shaped by stellar winds into columns that seem to reach upward forever. They aren't pillars of creation in the mystical sense, they're stellar factories, dense regions where gravity coaxes gas to collapse into new suns. The photograph became an icon, printed on posters and dorm walls, proof that science could be as beautiful as any painting. You float through something similar now, passing massive structures of gas that twist and curl like smoke frozen mid-dance. Each knot you see is a future star waiting to ignite, though it might take 1,000,000 years to do so. Patience is the universe's first virtue. You glide past one particularly dense clump where the light dims. Inside that shadow, hydrogen atoms are starting to huddle together, their faint gravity tugging on everything nearby. You can almost feel the tension building, the first spark of warmth hidden in the cold. Historians still argue whether the shapes of nebulae are sculpted more by magnetic fields or by radiation pressure from nearby stars. Some say the delicate curls are cosmic accidents, others claim they're inevitable patterns of physics repeating across scales. Whatever the truth, the result is mesmerizing. You can't help thinking that if clouds on Earth had souls, they'd dream of looking like this. A quirky tidbit floats into your thoughts. Nebulae glow not because they're hot, but because they're excited, literally. High-energy photons from nearby stars knock electrons loose in the gas. When the electrons fall back, they release light. It's basically cosmic fluorescence, space's version of a neon sign saying, "Now open for star formation." You chuckle softly. Even in the vacuum of creation, the universe has marketing flair. You weave between filaments that stretch for light years. The density is so low that you could fly through this cloud for centuries without touching a single atom. Yet somehow these thin wisps hold the seeds of everything. Future suns, planets, oceans, trees, and possibly a sleepy narrator whispering about all of it into a microphone. It's a strange, gentle irony that something so sparse holds the potential for so much fullness. As you float deeper into the nebula, you pass pockets where the gas thickens and begins to spin. Tiny eddies form, feeding larger whirlpools and beers. Gravity loves order disguised as chaos. Each whirlpool will someday collapse into a star surrounded by a disk of leftover dust. You can almost hear the faint whisper of turbulence, a cosmic lullaby played at frequencies far below human hearing. A mainstream aside flits by. The Orion Nebula, visible to the naked eye from Earth, is one of the nearest star-forming regions to our solar system. It's only about 300 light-years away, practically next door by cosmic standards. If you could see it up close like this, it would look just like what's around you now, bright, warm, alive. You realise that in a sense you're standing inside a snapshot of what once birthed your own sun. Historians still argue whether our solar nebula was triggered by a nearby supernova shockwave or by slow, inevitable collapse. The evidence leans toward the supernova theory, perhaps the same kind of explosion you've just left behind. It's humbling to think that our solar system began as fallout, born from a dying star's debris cloud. The universe really does love its recycling program. You drift near a newly forming star still hidden in its cocoon of dust. Infrared light seeps through, faint but insistent. The warmth reaches you, subtle as a sigh. It's strange to realise that this glow, weaker than a candle's flame, will one day blaze bright enough to outshine worlds. For now, it just hums quietly, patient and private. You find yourself whispering, "Take your time." Around you, the nebula continues to shimmer. Trails of dust stretch toward the distance like ribbons of smoke. Here and there, tiny pinpricks of light flicker, newborn stars breaking through their veils. Each spark feels like a heartbeat. You drift past one, its pale light washing over you, and you swear it feels familiar, like déjà vu across epochs. Perhaps it's because every atom in you remembers this. A quirky thought sneaks in. Somewhere far away, human astronomers are peering through telescopes at nebulae like this one, studying the same glow you're swimming through now. To them it's data, to you it's baptism. You want to tell them that the colours are softer than they think, that the silence is kind, that creation doesn't roar, it whispers. The deeper you move, the more alive the nebula feels. You sense currents within it, unseen forces sculpting and folding the gas. It's a reminder that even when everything looks still, the universe is always at work. You can't help smiling. Stars are already being planned, as methodically as any architect drafts a city. The raw materials of existence are just waiting for the right moment to shine again. And in the glow of all this potential, you realise something tender. Even the quiet parts of the cosmos are creative. Nothing is ever truly still. The ashes of the past are always building the future, grain by grain, breath by breath. You float there a moment longer, letting that thought settle into you like starlight, before drifting onward through the haze, toward the star that will someday become your own. You drift deeper into the nebula until it begins to tighten around you. No longer the sprawling cloud it was before, but a denser, swirling cradle. It feels almost like stepping into a heartbeat. The dust moves with purpose now, spinning inward in slow, deliberate spirals, pulled by something at the centre that you can't yet see. The light grows softer, warmer, more golden. You've arrived at the moment you've been approaching all along, the birth of our sun. 4.5 billion years ago, right here in a patch of the Milky Way not much different from 1,000 others, a cloud like this one decided to become a star. The gas gathers, folds, collapses. Gravity, once the patient sculptor, now becomes a conductor leading an orchestra of atoms. Hydrogen atoms fall toward the middle, colliding, heating, whispering to each other through motion until the pressure becomes unbearable. In the heart of the collapse, temperature soars past 10 million degrees, and suddenly, the long silence breaks. Hydrogen fuses into helium, a new light flares, hesitant at first, then confident. You can almost hear the universe sigh, finally. A mainstream historical fact glows faintly in your memory. Radioactive dating of ancient meteorites gives the sun's age as roughly 4.6 billion years. Scientists reconstructed this story piece by piece. Dust in rocks, isotopes in gas clouds, computer models of collapsing nebulae until the timeline became clear. You're watching that data come alive around you. The sun isn't born all at once, it's a slow ignition, a candle learning to burn steadily. You drift closer to the infant star, its light flickering through the mist. Around it spins a wide, flat disk of dust and gas. The solar nebula, whirling faster as it contracts. Tiny grains within it collide and stick, building clumps that will one day become worlds. The scene feels oddly familiar, like déjà vu written in starlight. The colours are muted, warm, like candlelight seen through amber glass. You're witnessing the first heartbeat of home. Historians still argue whether a nearby supernova sparked this collapse, or if it was simply the inevitable work of gravity. Some clues, like traces of certain short-lived isotopes in meteorites, suggest a supernova's fingerprint. If so, it means the sun was born in the echo of another star's death. You can't help smiling at the symmetry. One star's goodbye becomes another's hello. You pass through the glowing dust of the disk, the particles brushing by like misty rain. The farther you move from the centre, the cooler the material becomes. Here, water vapour can condense, carbon compounds can survive. Farther out still, ice begins to form, the seeds of comets that will someday carry oceans and organic molecules to the inner worlds. It's strange to think that in this chaos lies the recipe for life. Hydrogen, carbon, oxygen, nitrogen, all tumbling together like the ingredients of a cake that takes eons to bake. A quirky tidbit rises to the surface. Scientists think the early sun was surrounded by a disk so hot that its innermost regions glowed with infrared light, visible even across the young galaxy. If alien astronomers existed back then, they might have marked our newborn star in their charts as nothing more than bright young object 247. You grin, thinking of some distant species logging our origin as a footnote, unaware they're cataloguing the beginnings of poetry and pizza. The newborn sun grows steadier, brighter. It's still smaller than it will become, still feeding on the surrounding material. Solar winds, streams of charged particles, begin to blow outward, clearing away the lighter gases and sculpting the remaining dust into rippling patterns. You drift through these currents, feeling the tug and push of magnetism. It's like floating through invisible music, notes of plasma and field lines humming in concert. You glance back toward the edge of the nebula. Already gaps are forming in the disk where matter is condensing. Jupiter's core is gathering there, a massive swirl of gas. Farther in, smaller clumps are beginning to coalesce, rocky embryos that will become Mercury, Venus, Earth, and Mars. You realize the pattern forming beneath you is more than geometry. It's destiny, drawn in dust. Historians still argue over the details, how fast the planets formed, whether collisions or gentle accretion dominated, what set the boundaries between the inner and outer worlds. Every model offers a slightly different story, but all agree on the same refrain. It started here, in this warm, rotating disk around a brand new sun. The music of gravity was the same everywhere, but this melody happened to be ours. The sun itself is radiant now, though its light still flickers with youth. You can see flares burst from its surface, massive arcs of plasma looping and snapping. The sight is violent, yet somehow tender. It's a young heart learning to beat. Each flare sends waves of energy rippling through the disk, nudging dust, shaping orbits, sculpting the conditions for everything that will follow. You watch one eruption send a ripple of light so wide it makes the entire nebula shimmer, like a shaken snow globe. A mainstream note returns. When the solar wind finally cleared the last of the gas from this region, the planets had already formed, their fates sealed. The sun's energy from then on became the metronome of life on Earth, its steady light guiding everything from the bloom of flowers to the sleep cycle of humans staring up at it billions of years later. You find that thought oddly touching, that every morning sunrise is a continuation of this very moment, an unbroken thread from chaos to calm. You drift closer again, letting the sun's warmth wash over you. It's gentler now, the fierce blue-white of its birth softening into the familiar gold you know. You can almost imagine the planets forming behind you, small spheres still glowing from their own collisions, waiting for oceans, for clouds, for eyes to open beneath them. You want to tell the sun it's doing a good job, that its warmth will be loved by creatures it can't yet imagine. And so you linger there, in the glow of its infancy, surrounded by swirling dust and promise. The nebula hums softly around you, and for the first time in this long journey, you feel the faint tug of home. The light here is the same light that will someday fall on mountains and faces and pages. You float in it until you can't tell where you end and the sun begins. And for a quiet, infinite moment, everything just is. Calm, bright, alive. The newborn sun hums quietly behind you as you drift outward through its swirling disk of dust and gas. The light fades from gold to a soft copper glow, filtered by the haze of particles that fill this cosmic nursery. Here, the story turns sculptural. Tiny grains of rock and metal begin to bump into one another, stick for a moment, then spin apart and then collide again, gathering mass each time. It's not elegant, more like the universe playing with wet clay, but it works. The dust starts to clump into pebbles, the pebbles into boulders, the boulders into mountains adrift in orbit. You can almost hear the faint thud of collisions, a slow cosmic percussion. You're watching planets from stardust form, and the process is both violent and tender. Everywhere around you, the solar disk teems with motion. Some regions move faster than others, bands of gas sliding over one another like rivers of fog. Where turbulence gathers, vortices spin, tiny whirlpools that trap dust grains in their embrace. They look delicate like smoke rings, but each one is building something enormous. Gravity works its slow charm, coaxing order out of chaos. You float through it all, feeling oddly maternal toward these lumps of debris that don't yet know they're worlds. A mainstream historical fact hums through your mind. Scientists call this process accretion, and it's believed to have shaped the entire solar system within a few tens of millions of years. Meteorites found on Earth preserve the evidence, tiny calcium-aluminum inclusions dated to the solar system's earliest moments. They are the oldest solid things we've ever touched, older than Earth itself. To hold one is to touch the dust you're floating through right now, frozen in stone form. You pass a collision, two rocky bodies the size of small moons smashing together in a burst of molten light. The explosion sends ribbons of glowing debris arcing into space. Some of it will coalesce again, merging into a larger world. Some will drift away as fragments, maybe becoming asteroids or comets. You realize that every planet is born from violence, sculpted by impact. Creation here is messy, loud, and inevitable. You can almost hear the universe mutter. Good art takes a few drafts. Historians still argue whether the early planets formed gradually or through sudden, catastrophic mergers. Some models suggest that proto-worlds grew through steady accretion. Others claim that massive collisions between planetary embryos did the heavy lifting. Either way, the results are undeniable. From chaos came structure, from dust came destiny. The evidence is still written in the craters and scars of every world that orbits the sun today. A quirky tidbit drifts through your thoughts. In these early stages, Bates was full of molten rock droplets called chondrules, glowing like tiny embers as they cooled. If you could hold one in your hand, it would look like a bead of glass, millions of them glued together over time to form asteroids and planetesimals. You chuckle softly, realizing the universe started its world-building career by making cosmic marbles. As you drift farther out, the heat lessens. Here, beyond the warmth of the infant sun, the temperature drops low enough for ice to form. Water, ammonia, and methane freeze onto dust grains, making them sticky and heavy. This region becomes the birthplace of giants, Jupiter, Saturn, Uranus, Neptune. You can see them taking shape even now, immense spheres of gas forming around solid cores. Jupiter grows the fastest, its gravity sweeping up anything unlucky enough to come near. Saturn follows, its future rings already hinted at in the faint arcs of debris swirling around it. You can almost imagine the distant laughter of moons being born, each finding its place in orbit like dancers settling into rhythm. A mainstream aside surfaces, computer simulations show that Jupiter's early formation may have saved Earth. Its immense gravity likely deflected countless comets and asteroids that would have pummeled the inner planets, giving our fragile world a chance to form and survive. You glance at the forming gas giant and feel a surprising fondness. For all its storms and vanity, Jupiter is the quiet guardian of life yet to come. Closer to the Sun, smaller rocky planets take shape: Mercury, Venus, Earth, and Mars. They're still molten, their surfaces oceans of magma. The collisions continue, each impact shaking worlds into new forms. One especially violent crash sends an entire chunk of molten rock spinning off Earth's side. It will become the Moon, faithful companion and tidal choreographer. You watch it cool beside its glowing parent, the first of countless dances they'll share. Historians still argue about the Moon's exact origin. The prevailing giant impact theory says a Mars-sized body, Theia, struck the early Earth, merging partly and flinging debris into orbit. That debris, over time, gathered into the Moon. Some alternative models suggest slower mergers or multiple impacts, but whichever version is true, you can see the result glowing faintly ahead, a newborn satellite shimmering silver in the darkness. Even now, it's beginning to stabilize Earth's rotation, slowing her spin, setting the rhythm that will guide tides and seasons. A quirky thought amuses you. If you could fast forward this cosmic construction site, you'd see planets shifting places like restless roommates, swapping orbits before settling down. Jupiter's migrations alone may have reshaped the entire system, herding asteroids, sculpting the gaps in the belt, and ensuring stability where chaos once ruled. Gravity may not have hands, but it sure knows how to organize a neighborhood. You float back toward the sun again, watching the entire solar system take shape like a grand mosaic. The dust thins, the collisions slow, and the orbits settle into harmony. The once turbulent disk now glows faintly in the sun's light, a shimmering halo of leftover debris, the early zodiacal cloud. You realize this is the afterglow of creation. The pause before life begins to stir. The silence feels earned. Every atom here has found a purpose. The violent noise of collisions has faded into a calm gravitational hum. You look around and recognize the architecture of home, the familiar spacing of worlds, the delicate balance of their paths. The solar system at last is a symphony finding its tune. And somewhere, on one still cooling planet swathed in steam and molten rock, the ingredients of oceans wait for rain. The sun watches, proud and steady, unaware that its light will one day illuminate eyes that look back in wonder. You hover above that spinning blue embryo, knowing what's coming next, and whisper softly into the void, "Welcome home." The blue world beneath you is still unrecognizable, an ocean of molten rock wrapped in clouds of steam, ammonia, and carbon dioxide. Lightning forks through the haze like veins of silver fire. Each strike splits molecules apart, stitching them back together in new and improbable ways. This is Earth's hidden origin, a slow symphony of chemistry that doesn't yet know it's composing the score of life. You descend through the haze, feeling heat rise from below. The air tastes of iron and sulfur. Somewhere in the distance, volcanoes roar, hurling minerals into the sky. The planet is restless, young, and utterly beautiful in its chaos. Beneath the crust, heavy elements forged long ago in dying stars. Iron, nickel, gold sink inward, pulled by gravity's relentless call. The core forms first, glowing liquid metal spinning at furious speed. Around it, a mantle of silicates churns like a pot of magma stew. Every atom here is disjunct but newly arranged. Recycled stardust now learning new tricks. You can almost feel the heartbeat of the planet beginning to pulse, a slow rhythm that will one day sync with the moon's pull and the tides of distant oceans. A mainstream historical fact whispers through your thoughts. Earth likely took shape about 4.54 billion years ago, forming from the accretion of planetesimals left over after the sun's birth. Evidence for this age comes from radiometric dating of meteorites, the unspoiled time capsules of that chaotic era. Each one tells the same story. Earth began as dust and violence, then cooled into patience. As you hover above, you notice the surface beginning to darken. The molten glow fades in patches, replaced by crust, thin, cracked, fragile. Asteroids still rain down, slamming into the ground with world-ending force, yet somehow the planet persists. Each collision adds new material, delivering metals, water, and carbon compounds from the outer solar system. You can almost imagine the universe tossing the ingredients into a cosmic cauldron, muttering, "Needs more oxygen." Historians still argue whether Earth's water came from these comets, or from reactions deep within the planet's mantle. Some models say icy bodies delivered it. Others claim hydrogen and oxygen formed water in situ. Either way, you can see steam thickening above the cooling crust. Soon it will condense, fall as rain, and fill the first oceans, You want to shout encouragement. Yes, that's it, more rain. But the sky is already listening. A quirky tidbit bubbles up. The first oceans likely boiled for millions of years, trapped under an atmosphere of carbon dioxide and methane. They would have been acidic, toxic, and far too hot for comfort. Yet within those waters, the seeds of life were already stirring. The irony isn't lost on you. Life's cradle was basically a cauldron of poisoned soup. Apparently evolution likes a challenge. You drift lower, close enough to see the volcanic plains hardening into basalt, the first continents rising timidly through the haze. Each eruption releases more gases, carbon, nitrogen, sulfur thickening the sky. The air glows orange under the young sun's weaker light. You can barely see the stars beyond it. It feels like standing inside the lungs of the planet as it takes its first breath. Beneath you, chemical reactions spark along mineral surfaces. Simple molecules, ammonia, methane, water, collide and fuse, forming amino acids and sugars. It's chemistry, yes, but it feels intentional, like the universe is experimenting with the alphabet of existence. Somewhere, in a puddle warmed by geothermal heat, these building blocks will meet and form the first fragile polymers. You can almost hear the faint, excited whisper of RNA rehearsing its first line. Historians still argue where life began, in deep-sea hydrothermal vents, in warm surface pools, or even in ice-crusted comets that seeded the Earth. Each theory carries its own beauty. Perhaps it happened in several places at once, life arising not from a single spark but from a choir of them, each singing the same song in different keys. You like that idea better. It feels more like the universe you've been travelling through, redundant, extravagant, endlessly creative. A mainstream aside glimmers in your memory. Isotopic traces in rocks from Western Australia suggest microbial life existed as early as 3.5 billion years ago. That means it took only a few 100 million years for chemistry to find consciousness. In cosmic terms, that's practically overnight. Earth wasted no time. She was eager to start dreaming. You rise higher, watching the planet cool. The sky darkens to a heavy grey, then deepens to blue as the first stable atmosphere forms. Steam condenses into rain that hisses against the still warm crust, filling basins, carving valleys. Rivers form, rushing toward lowlands that will become oceans. The surface gleams like liquid glass. You feel the temperature drop, the air clearing just enough for sunlight to sparkle faintly on the waves. It's a quiet miracle. A quirky thought crosses your mind. At this point, the moon is closer than it will ever be again, looming enormous in the sky, 50 times brighter than you know it today. Its gravity churns the early seas into massive tides, stirring the soup of creation. You imagine standing on a primitive shoreline, watching the moon's reflection ripple across the water. It's not hard to believe that something might soon climb out to meet it. Historians still argue when Earth's magnetic field first switched on, but it was likely around this time, powered by the churning of molten iron in the core. That invisible shield will protect the planet from solar radiation, preserving its atmosphere and giving fragile life a fighting chance. You glance upward toward the sun, remembering its tempestuous flares, and think, you're fierce, but she's ready for you now. The world below glows with potential. The continents shift slowly, grinding against each other, like puzzle pieces searching for fit. The air cools, the oceans deepen, and somewhere within them molecules are linking arms, whispering secrets about replication, about memory, about becoming more than chemistry. The iron in Earth's core hums softly, a lullaby from the stars that made it. You hover in the quiet, realizing how much of yourself is already here. The calcium in your bones, the iron in your blood, the oxygen in your breath, all forged in the furnaces you've passed through tonight. This planet isn't new material, it's an old story rewritten. The stardust you've been chasing has finally come home, ready to learn how to dream. The surface of Earth is no longer a molten scar, but a patchwork of oceans, volcanic islands and endless grey skies. The air still smells faintly of sulphur, and lightning still scribbles its jagged handwriting across the clouds. But something new stirs beneath the waves. The chemistry you watched begin in Section 14 has grown restless. It's learning rhythm, replication, persistence. You float just above the water, watching bubbles rise from the vents below. The sea smells metallic, ancient, alive. In these depths, life learns to shine. You drift down through the dark into a field of hydrothermal vents. They tower like chimneys, each one belching mineral-rich plumes into the ocean. The water is black, yet streaks of green light flicker here and there. Primitive bioluminescence, chemical lanterns announcing that metabolism has arrived. Molecules arrange themselves into membranes. Membranes form cells. Cells cluster into colonies. You can't help smiling. The universe has finally made something that can copy itself. After billions of years of silence, the cosmos is humming a new tune, and it's being played by microbes. A mainstream historical fact surfaces. Fossilized microbial mats called stromatolites, found in Australia and Greenland, are more than 3.4 billion years old. They prove that photosynthetic life appeared astonishingly early, transforming the atmosphere long before animals or trees existed. You imagine those first mats spreading across shallow seas, tiny architects of oxygen who had no idea they were designing the sky. You rise toward the light filtering through the water. At the surface, the glow is faint and copper-green, but the microbes are already learning to harvest it. Photosynthesis begins, not quite as we know it yet, but close enough. Carbon dioxide dissolves, sunlight splits water, and oxygen seeps into the air molecule by molecule. It's a quiet revolution, and it will change everything. You picture the ocean as a vast classroom where sunlight teaches atoms to think. Historians still argue whether life began in these vents or in tide pools exposed to cycles of wet and dry. Both have evidence, and both feel right. Perhaps the truth is that life, impatient and prolific, tried every available laboratory until one worked. You like that version. It makes the universe sound stubbornly hopeful. A quirky tidbit drifts into your mind. Early cyanobacteria released so much oxygen that it reacted with dissolved iron in the oceans, staining the sea blood red and precipitating vast layers of rust that would one day become the world's iron ore deposits. You chuckle softly. Your red blood cells are coloured by ancient bacterial waste. The next time you cut your finger, you'll be bleeding geology. The atmosphere begins to shimmer as oxygen builds. For hundreds of millions of years it accumulates invisibly, until one day the great oxygenation event hits, a planetary makeover so dramatic it nearly wipes life out. The sky turns blue for the first time, methane freezes, and snowball Earths come and go. Yet life endures, tucked into warm oceans and deep rock pores. You can feel the planet breathe through the ice, patient, waiting for another chance to bloom. A mainstream aside floats by. About 2 billion years ago, cells discovered cooperation. One cell swallowed another, and instead of digesting it, kept it as a helper. That captive became the mitochondrion, the powerhouse of complex life. You can almost hear the microscopic negotiation. You handle the energy, I'll handle the paperwork. It's one of evolution's greatest mergers, proof that sometimes survival is about partnership, not power. You watch the oceans darken with new complexity. Multicellular algae drift like ribbons, sponges filter the currents, jelly-like colonies pulse in slow motion. Bioluminescent flashes glitter beneath the waves, constellations of living stars mirrored below the sea's surface. You realize that starlight has found a second home, not only shining from above, but glowing from within. Historians still argue when true multicellular organisms first appeared. Some fossils hint at them 2.1 billion years ago. Others insist it happened much later. The timeline blurs, but the pattern is clear. Life, once small and timid, keeps testing new shapes. The same fusion that built stars now fuels metabolism. Tiny suns burning inside cells. You can almost hear the cosmic echo, fusion in the heavens, respiration in the sea. A quirky note makes you grin. Some biologists think early photosynthetic bacteria caused Earth's first pollution crisis, filling the air with oxygen toxic to most life at the time. Essentially, the planet's first environmental catastrophe was caused by plants. You imagine the bacteria protesting, "We were just breathing," and the rest of life yelling, "Could you not?" It's oddly reassuring. Chaos and unintended consequences seem baked into the recipe for progress. You rise through the clouds of plankton, feeling the oxygen thicken around you. Lightning flashes overhead, not as punishment, but as applause. For the first time, there's a smell faintly like rain. The world is still mostly water, but continents are stirring under the surface, drifting on molten plates, waiting for their debut. Above the waves, the sky is clear enough for sunlight to reach unfiltered. You watch as light dances across ripples and think, This is how consciousness begins, with photons teaching molecules to pay attention. Historians still argue what consciousness is, but here in this slow dawn it's simply awareness. The first cell noticing change, adjusting, persisting. That humble response will, given time, become thought, curiosity, and eventually questions like the one you're asking right now. Life doesn't leap from nothing to mind. It climbs, patiently, one adaptation at a time. You drift higher, out of the atmosphere, looking down on the shimmering planet. It's blue now, truly blue. The oxygen tinting oceans and sky alike. White clouds swirl in slow spirals. From here, Earth finally looks alive, though you know she's still mostly microbes and algae. Yet the pattern is undeniable. Complexity begets more complexity. Starlight has become chemistry, chemistry has become metabolism, and metabolism is already dreaming of motion. You think of all the suns you've passed, their furnaces, their deaths, their gifts of dust, and realize this is their masterpiece. The elements forged in stellar hearts have learned to arrange themselves into living art. Every green leaf, every pulse of light in a jellyfish, every heartbeat to come, all are continuations of that first fusion spark. You linger a moment longer, watching the oceans glitter like liquid galaxies. The thought occurs that maybe stars and life are the same thing in a different tempos. One burns fast, the other slow, both converting matter into meaning. It's a comforting symmetry. You smile, whispering, "Shine on, little planet," and drift upward again, following the path of light that once began inside a sun. From the silent dark of orbit, Earth glows like a sapphire candle, fragile and impossibly alive. You hover there for a moment, suspended between starlight and memory, and feel a strange warmth, because everything happening below is already inside you. Tonight's path has come full circle. The human connection you've been chasing begins here, where the cosmic story folds into skin and breath and bone. You descend through the sky, slowly, the atmosphere glowing orange around you, a curtain of air whispering with ancient atoms. Each molecule is a relic. Oxygen from photosynthetic microbes, nitrogen from volcanoes, carbon once trapped in the bellies of dying stars. The air isn't just air, it's autobiography. You land into a meadow lit by moonlight. The grass sways, silver-tipped, shimmering with dew. Every blade contains carbon drawn from sunlight, hydrogen that once floated in a nebula, oxygen that escaped a star's furnace. You kneel and run your hand through it, though the gesture is more metaphor than motion. You're touching the continuation of fusion, the proof that the cosmos learned tenderness. The calcium in your fingertips is the same calcium forged in some red giant's final heartbeat. The iron in your blood, the same iron that marked the death of a stick. You've carried the universe home without even noticing. A mainstream historical fact hums in your thoughts. Carl Sagan popularized the phrase "we are made of star stuff" in the 80s, but the idea traces back to mid-20th century astrophysicists like Burbage, Fowler and Hoyle. Their calculations showed that every element heavier than helium had to come from stellar fusion or supernova explosions. Humanity didn't invent poetry about stars. It discovered that poetry was already written into matter. You look up at the night sky as this. The Milky Way stretches overhead, a river of light that once felt infinite and remote. Now you know its intimacy. Each glimmering point is family, some long gone, some still burning. The air between you and those stars is filled with dust, microscopic grains drifting since before Earth existed. Brushing your face as you breathe, you're inhaling history and exhaling gratitude. Historians still argue how humans first understood this connection. Ancient cultures saw it intuitively. Egyptians aligned pyramids with Orion, the Maya mapped Venus. Polynesians navigated entire oceans by star memory. Modern science only confirmed what mythology already guessed, that we belong to the sky. You find that comforting. Whether through telescopes or stories, we've always been trying to remember where we came from. You walk along a small stream. The water glows faintly in the moonlight, whispering across stones. Each droplet contains hydrogen, created in the first minutes after the Big Bang, literally the oldest matter in your body. The same atoms that cooled galaxies now move through your veins as blood. You dip your hand into the stream, feeling it slide across your fingers. It's colder than you expected, as if reminding you that eternity prefers simplicity. A quirky tidbit makes you laugh. Technically, your body is about 60% water, so by weight, you're mostly made of hydrogen, the universe's simplest and oldest element. You're an ancient thing pretending to be modern, a walking relic of cosmic history disguised as a person with a smartphone. If that isn't humility wrapped in absurdity, nothing is. You pause to listen. The night hums softly, insects, wind, distant waves. It's strange to realize that all this sound, the rustle of leaves, the rhythm of a heartbeat, is matter vibrating in intricate patterns first set by fusion. The energy radiating from stars billions of years ago still echoes here as a music, conversation, laughter. You think, maybe stars don't die, they just change languages. Historians still argue when self-awareness emerged, when life first looked back at the universe and said, "I am you." Some say it was the moment early humans stared at constellations and gave them names. Others point to the first cave painting, a handprint made of ochre, a stardust fingerprint declaring existence. Either way, consciousness is the cosmos achieving nostalgia. You are the universe remembering itself. You wander farther through the meadow. Fireflies blink around you, tiny imitations of galaxies, each one burning fuel in miniature. Their light feels both familiar and anew. You remember the neutron star collisions that made gold, and suddenly the flecks of amber on a firefly's wing look priceless. The connection isn't metaphor anymore, it's literal. You're surrounded by reincarnated suns wearing the disguise of small, fragile lives. A mainstream note rises. Even the hemoglobin that carries oxygen in your blood depends on iron's ability to bond and release. Without that element, born in a supernova, you'd never take a single breath. The same goes for calcium in your bones, magnesium in your cells, and phosphorus in your DNA. Each chemical reaction inside you is an echo of ancient fusion equations. Your metabolism is a tiny controlled star. A quirky observation nudges you. The next time someone complains that they're burned out, you might remind them that they literally are, slowly radiating heat from chemical fire that started in stellar hearts. We're all just slightly cooler, slower burning stars in shoes. You sit on a small hill and watch dawn approach. The horizon glows pale silver, then rose, then gold. The first rays of sunlight spill across the field, and for a moment, it feels as though the sky recognizes you. Every morning, photons born in the sun's core 10,000 years ago finally escape and reach Earth, landing softly on your skin. Light that began its journey before pyramids existed ends its pilgrimage as warmth on your face. You close your eyes, letting it sink in. Historians still argue whether humans are unique in understanding this cosmic inheritance, or if intelligence is sprinkled throughout the stars, quietly recognizing itself elsewhere. Maybe there are other creatures on distant worlds doing what you're doing now, feeling their starlight on the borrowed skin. The idea doesn't feel lonely, it feels inevitable. You inhale, filling your lungs with borrowed air, and exhale slowly. The atoms scatter, destined to drift, to be reassembled someday into something else. Maybe a raindrop, a leaf, another person, another world. You realize you've never truly owned anything, not even your body. It's all rental property from the cosmos, temporarily organized into you, and that somehow feels perfect. You look once more toward the sky, your heart beats steady, your breath even. The stars above no longer seem distant. They're reflections of the same fire that burns quietly inside your chest. The connection is complete, from hydrogen to human, from light to thought. The universe, it seems, didn't just make you, it became you just long enough to notice its own beauty. The sky above you turns deeper, not with night, but with sheer abundance, so many stars that it looks like the Milky Way has spilled itself open. You rise through the atmosphere again, leaving behind the quiet meadow and rejoining the greater rhythm. From here, Earth's lights fade into freckles of gold along its shadowed curve, and the galaxy stretches out before you. It feels familiar now, like stepping back into a crowded, glowing city you've always belonged to. This is where the galactic fireworks never stop. Stars being born, living, dying, and being born again. You're about to witness creation on its grandest scale. You drift toward the spiral arms of the Milky Way, vast ribbons of gas and dust winding around the galactic core. Each arm hums with the same story you've followed tonight. Gravity compressing clouds, stars igniting, matter recycling. From a distance, the galaxy seems tranquil, a perfect swirl of light, but inside it's a storm. Entire constellations are forming right now, millions of suns bursting to life in regions so dense that space looks bruised with colour. You can almost hear the static hiss of radiation, space's version of applause. A mainstream historical fact flickers into your thoughts. In 1924, Edwin Hubble proved that galaxies were separate, island universes, not just clouds within our own. That discovery expanded humanity's map of the cosmos from one galaxy to billions. Now, drifting through this single spiral arm, you tell Leo that even billions might be an understatement. There's something unquantifiable about infinity. It refuses to be counted. You pass through a cluster of young stars still wrapped in glowing veils of dust. They pulse with pale blue light, each one enormous and short-lived, burning 10,000 times brighter than the sun, but destined to die within a few million years. Around them, debris disks sparkle like necklaces, promising future planets. The sight feels almost decadent, like the universe showing off. You whisper, "All right, we get it, you're dramatic," and the cosmos twinkles back unbothered. Historians still argue about how many stars form each year in the Milky Way. Some estimates say 1 or 2, others suggest 10. The truth shifts with every new telescope, every clearer image of some hidden nebula. What's certain is that the galaxy is always busy, always sculpting, always throwing cosmic parties where light is both guest and decoration. You drift toward the galactic core where the density of stars increases until the night becomes white. At the centre, a supermassive black hole, Sagittarius A, spins quietly, its gravity shaping the orbits of everything around it. You can't see it, but you can sense its influence, a silent conductor keeping billions of stars in rhythm. The scale is overwhelming yet oddly reassuring. Even chaos obeys patterns here. A quirky tidbit surfaces. When viewed in radio waves, the Milky Way glows brightest, not from stars but from clouds of hydrogen, remnants of old supernovae. If human eyes could see in those frequencies, the night sky would look like a cosmic lava lamp, rippling waves of colour constantly changing. You grin, imagining the universe as a teenager's bedroom decor, endlessly rearranging itself. You move outward again, past the dense heart into quieter regions where stars are older, redder, slower. Here the galactic fireworks soften into embers. These ancient suns have burned through their hydrogen, content to drift through twilight. Some have planetary systems long frozen over. Others may still harbour warmth in hidden oceans. You realise that somewhere, on some faraway world, another being might be looking up right now, wondering about you. Historians still argue whether life could exist in these distant regions, far from the galaxy's bright arms. Some models suggest radiation levels are lower, making them safer for fragile ecosystems. Others argue that the scarcity of heavy elements makes complex chemistry unlikely. Either way, the debate is a kind of optimism. It means scientists believe life could happen anywhere. You drift through an open cluster, hundreds of newborn stars huddled close like siblings. Their combined light bathes the dust around you in pink and violet hues. The temperature rises. You can feel radiation prickle gently along your skin. You imagine this cluster as a cosmic nursery where gravity hums lullabies and every lullaby ends with ignition. The idea makes you laugh softly. The universe might not know tenderness, but it certainly knows rhythm. Beyond the cluster, you encounter the remains of something older, a supernova remnant expanding in wisps of emerald gas. Its shape is delicate, almost floral, like petals unfurling in zero gravity. You recognize the pattern instantly. You've seen its kind before. Each filament glows faintly with the signatures of heavy elements, the fingerprints of a long-dead star. You drift through it reverently, whispering thanks to a stranger who gave you the atoms in your veins. A mainstream note echoes. Astronomers estimate that in every second, across the observable universe, 1 to 3 stars explode as supernova. That means that even as you breathe, new elements are being forged somewhere. The cosmos never sleeps, it simply cycles. You imagine the night sky as a living organism, inhaling hydrogen and exhaling gold. You turn back to admire the galactic disk from above. The Milky Way stretches below you in a soft, glowing plain, its spiral arms glittering like trails of spilled diamonds. Beyond its edges lies the intergalactic void, black, silent, dotted with faint smudges that are other galaxies, each one with its own stories of creation and collapse. The vastness no longer frightens you. It feels welcoming, like a library, where every star is a book waiting to be opened. A quirky thought crosses your mind. If galaxies are cosmic fireworks, then the dark between them is applause, the quiet acknowledgement that brilliance cannot exist without contrast. You float in that silence for a while, feeling its honesty. There's peace in knowing that even the universe pauses to admire its own work. Historians still argue whether galaxies die or simply fade into red, cooling slowly as their stars burn out. Either way, nothing truly ends. The light that leaves these stars will travel forever, touching worlds that haven't yet formed. The show never really stops. It just moves to a different part of the sky. You take one last look at the Milky Way before moving on. Its spiral arms shimmer faintly, the rhythm of creation still pulsing through them. Somewhere down there, Earth spins, its lights tiny, its voices soft. And yet from this height, you can see the pattern that unites it all. Hydrogen to helium, helium to life, life to wonder. The fireworks continue, infinite and kind, and you find yourself whispering the only words that feel big enough. Thank you. You linger in the quiet between spiral arms, where the stars grow sparse and the dark feels older. It's here that questions gather like drifting dust, curious, unanswerable, persistent. The universe, for all its glitter and spectacle, still keeps its secrets close. You find yourself drawn toward one of them, the debate of origins, the question of where the heaviest elements, the rarest metals, and perhaps even life's earliest ingredients truly come from. You've seen supernovae, you've watched neutron stars collide, but even now, after billions of years of observation, science isn't entirely sure how the cosmic ledger balances. The mystery hums around you like a low, distant note vibrating through the void. You drift near a patch of faint starlight, a distant dwarf galaxy shimmering like spilled dust, and its stars are old, ancient enough to predate much of the Milky Way. Their spectra show almost no heavy elements at all, only hydrogen and helium with the faintest trace of lithium. Astronomers call these population 2 stars, the descendants of the very first lights that ever shone. Looking at them feels like looking backward through time, peering into a universe that hadn't yet learned colour. You can sense the absence of metals in their light. It's thinner, paler, simpler. The cosmos here is still learning how to decorate itself. A mainstream historical fact surfaces. For decades, scientists assumed all heavy elements were born in supernovae. But in the early 21st century, observations of gravitational waves from neutron star mergers forced a revision. Those collisions, not explosions, seem to create much of the gold and platinum in the universe. Yet the math still doesn't add up neatly. Some isotopes appear more abundant than either process can explain. It's a puzzle, a cosmic bookkeeping problem written in the periodic table. You move closer to the faint galaxy, tracing its slow rotation. A thin fog of gas drifts through it, too diffuse for new stars to form. This place is old and tired, a museum of stellar relics. But as you watch, a ripple passes through the gas, a faint tremor of gravity from a nearby merger. The disturbance reignites a few clouds, collapsing them into pinpoints of light. Even now, after billions of quiet years, the universe can't resist making more stars. You smile. Creation is apparently a bad habit the cosmos can't break. Historians still argue about how the first stars formed. Without metals to cool their gas clouds, they should have been enormous, hundreds of times more massive than the Sun, and short-lived. Yet no direct evidence of these population 3 giants has ever been found. Did they really exist, or have we been chasing ghosts? Some astronomers believe faint infrared signals from the earliest galaxies, recently captured by the James Webb Space Telescope, may finally reveal them. Others insist we're still staring too late, too far after the dawn. The debate continues, polite but passionate, whispered between observatories on mountaintops. A quirky tidbit crosses your mind. The heaviest naturally occurring element found on Earth is uranium, number 92, but traces of even heavier ones, neptunium, plutonium, still appear in cosmic dust. They decay so quickly that their presence means something nearby must have recently forged them. Somewhere right now, the universe is still forging its alphabet's most complex letters. You like that thought. Physics as ongoing poetry written in radiation instead of rhyme. You glide farther into intergalactic space, where the faint glow of distant galaxies forms a delicate web. Between the filaments, enormous voids stretch, regions hundreds of millions of light years wide, almost empty. It's unsettling at first, this vast absence, but soon you feel its rhythm. The galaxies are beads on invisible threads, gravity's embroidery stretching across infinity. The spaces between are not failures, but structure, the silence that lets the music breathe. Historians still argue what these cosmic filaments truly mean. Are they the skeletal framework of dark matter, unseen scaffolding upon which galaxies cling? Or are they something stranger, the echo of quantum fluctuations amplified by gravity? You drift among them, unable to tell where matter ends and imagination begins. Perhaps the difference doesn't matter. Both are forms of curiosity. A mainstream aside flickers through your mind. Dark matter makes up about 85% of all mass in the universe, yet it remains invisible, detectable only through its gravitational pull. Dark energy, its mysterious cousin, appears to push galaxies apart, accelerating cosmic expansion. Together, they compose the majority of everything, and we don't know what they are. You can't help laughing softly. Humanity loves to map the unknown, but most of the universe remains politely refusing to show its face. You encounter a faint glimmer ahead, a quasar, the bright core of a young galaxy powered by a ravenous black hole. Its jets stretch for thousands of light years, slicing through the dark like cosmic searchlights. Around it, the surrounding gas glows incandescent blue, rich with newly minted elements. Here, in this violent engine, matter and energy blur, and the boundary between destruction and creation dissolves entirely. You can almost hear the roar. Perhaps this too is part of the debate. Do quasars contribute to element formation? Some think they help spread metals across galaxies. Others see them as purely consumers, not creators. Either way, their light has travelled billions of years to find you. A quirky reflection sneaks in. If light from distant galaxies takes billions of years to reach Earth, then somewhere out there the universe is still young, still learning to fuse hydrogen for the first time. Time isn't linear here. It's layered, folded, echoing. The cosmos is both ancient and newborn, depending on your vantage point. You realise that when is a relative question. In an infinite stage play, you float among the faint galaxies, letting your mind stretch alongside the light. The unanswered questions no longer feel frustrating. They feel like invitations. Maybe the point isn't to know exactly where every element came from, but to marvel that they came at all, that the universe is patient enough to keep experimenting, refining its recipes. You think of scientists on Earth arguing over spectra and equations, each one unknowingly carrying the same stardust in their veins as the subjects they study. The symmetry is perfect. Historians still argue if the universe will end in fire or frost, whether expansion will stretch galaxies so far apart that stars die in isolation, or whether gravity will one day pull everything back into a single point, ready to start again. Either future feels too distant to fear. For now, there's still motion, still light, still curiosity. The cosmos hums softly around you, undecided but unconcerned. You turn back toward the Milky Way's faint glow, visible across the dark like a lantern. Behind you, the rest of the universe stretches infinitely, full of mysteries still unsolved. You realize that the debates themselves, the arguments, the revisions, the endless pursuit of why, are part of the same creative process that births stars. Knowledge, like fusion, burns, and so you drift forward, letting the questions follow like constellations that will never quite resolve but will always guide the way. You glide through the quiet between galaxies, and for a while the silence feels absolute. The starlight behind you fades into a faint haze, like embers cooling after fireworks. But if you listen closely, if you stretch your thoughts far enough, you can almost hear the slow ticking of time. The universe isn't finished. It's still changing, still dreaming. You've seen the beginning, the birth of stars, the forging of elements, the rise of life. Now you're drifting into the long tomorrow, where the future of element making unfolds in slow motion. The story continues, but the tempo is different now, measured, patient, inevitable. Ahead, a galaxy shimmers faintly, older than most, its spiral arms starting to thin. The blue-white blaze of youthful stars is giving way to the steady orange of survivors. You pass through the halo of aging suns, and the light feels warmer, softer, like firelight at the end of a long night. Here, hydrogen grows scarce. The furnaces still burn, but the fuel is running low. The universe is entering middle age, and the party is winding down. A mainstream historical fact flickers in your mind. Astronomers predict that star formation across the cosmos peaked about 10 billion years ago. Since then, the rate has slowed by more than 90%. Galaxies once ablaze with light now form only a handful of new stars each year. In another few trillion years, that number will dwindle to zero. Yet even then, the existing stars will continue fusing, shining steadily in the dark. The cosmos doesn't go out with a bang, it fades gracefully, like the dimming of a candle too wise to protest. You drift near a red dwarf, a small quiet star that burns with a patient glow. Unlike the blue giants that live fast and die young, this one will shine for trillions of years, longer than the current age of the universe itself. You hover near it for a while, comforted by its steadiness. It's the universe's version of a thrift shopper. Tiny, efficient, utterly unwilling to waste energy. You grin softly. If immortality has a colour, it's this muted crimson. Historians still argue how the last stars will die. Some predict black dwarfs, stars that cool so completely they no longer emit light, their heat fading into silence. Others propose that quantum tunneling might allow protons to decay, slowly erasing matter itself. Either way, the timeline is incomprehensible. Numbers so large they lose meaning. You can almost feel centuries flutter past you like seconds. Time, once a river, has become an ocean. A quirky tidbit drifts through your thoughts. If you could somehow wait around for the final era of starlight, you might see stars made entirely of degenerate matter, objects that fuse through quantum tunneling instead of gravity. They'd burn faintly blue for trillions of years, tiny sparks against an expanding void. Cosmologists have nicknamed this future the degenerate era, which sounds more like a rock band than the last chapter of existence. You chuckle, imagining ancient red dwarfs playing backup. You move farther out, where galaxies have thinned into faint smudges. Expansion is accelerating now. Space itself is stretching, dragging everything farther apart. The cosmic microwave background, the echo of the Big Bang, has cooled to near absolute zero, a whisper almost lost. The universe feels tired, but not sad. It's simply following its rhythm, letting entropy write the next verse. A mainstream aside hums through your memory. Cosmologists estimate that in about 100 trillion years, star formation will cease entirely. The night sky, once blazing with constellations, will grow dark, yet gravity will persist, pulling remnants together. White dwarfs, neutron stars, black holes. Occasionally two will collide, releasing brief flashes of light. Even in the twilight, the cosmos finds ways to sparkle. You pass one such collision, a pair of dead stars merging silently, releasing a soft flare of X-rays before fading into nothing. The light travels outward, crossing more empty space than galaxies can count. You realize that even at the end of everything, there will still be echoes, faint whispers of brilliance refusing to disappear completely. Historians still argue what comes after that. Some theories propose that black holes will dominate, slowly evaporating through Hawking radiation over unthinkable timescales. Others imagine a cosmic rebirth, a big bounce, where the universe collapses and expands again, reusing its atoms like a poet rewriting an old line. The arguments sound human, half realism, half hope. You drift toward a cluster of black holes, each spinning quietly, invisible except for the faint halos of light bending around them. They seem almost peaceful, like campfires of gravity in an infinite forest. One of them flickers as a star strays too close. The star is shredded, its matter spiraling inward in a final burst of brilliance. You can't help but smile sadly. Even in death, stars still find a way to illuminate. A quirky realization dawns on you. If black holes truly evaporate, the last light in the universe will come from their final size, tiny bursts of radiation, quick and soft like cosmic fireflies. After that, the dark will be complete. But maybe you think that's not an ending at all. Maybe it's a pause, a rest before the next creation. You turn to look back across billions of light years. The galaxies stretch like faint smears across the expanding horizon, their light redshifted until it's almost invisible. The silence feels enormous, but you've learned that silence is never empty. It's the echo of everything that's ever happened. Somewhere in the static between atoms, new physics may already be stirring, laws bending toward a new beginning. Historians still argue whether time itself will continue forever or loop back on itself. The truth may be unknowable, but it hardly matters. You sense that whatever comes next will carry the same pattern. Energy finding form, form learning awareness, awareness gazing back at the stars. The cycle might be endless because wonder is endless. You let yourself drift, feeling no urgency, no fear. The universe may cool, but curiosity burns steady. The elements forged in ancient suns still circulate through galaxies, through planets, through you. Even when the last star fades, their legacy remains in the structure of thought, in the geometry of memory. You smile because you finally understand creation doesn't end when the light goes out. It continues in whoever remembers it. The silence deepens until even your thoughts seem to slow, stretched thin across the dark. You've followed this story from the first spark of hydrogen to the quiet death of galaxies, and yet somehow it feels like you've only circled back to where it all began. Around you, the faint light of ancient stars shimmers like dust caught in an eternal exhale. You hover in that soft twilight, neither past nor future, and realize that everything, the Big Bang, the stars, the elements, the rise of life, has been leading to this moment of understanding. You're no longer just an observer drifting through cosmic history. You are what the universe has been trying to say all along. You, the star-stuffed dreamer. You turn slowly, letting the panorama of creation unfold behind your eyes. Every flash, every collision, every breath of light is part of your inheritance. You carry it in your bones, your blood, your thoughts. You are hydrogen that learned how to wonder. The stars didn't simply make you, they became you, rearranged their atoms into the fragile pattern of awareness that now looks back at them and whispers, "Thank you." It's a strange kind of miracle, one that doesn't need divinity to feel divine. Below you, a planet spins quietly in the dark, small, blue, wrapped in a gauze of clouds. Earth, old friend, turning still. You descend gently through thin layers of atmosphere, through pale auroras that shimmer like curtains of memory. The surface glows faintly in the starlight. Cities wink like constellations stitched by electricity. Rivers gleam silver under the moon. You can see where the light of humanity pools, fragile sparks scattered across the dark like echoing galaxies. They flicker, they fade, they reignite. The rhythm is familiar. It's starlight with a heartbeat. A mainstream historical fact surfaces as you watch. When Voyager 1 turned its camera back toward Earth in 1980, it captured a single pixel, the pale blue dot. Carl Sagan's words still echo across time. That's here, that's home, that's us. You feel the weight of that truth pressing softly against your chest. Every love, every war, every lullaby, all of it contained in that pinprick of light. The entire human story unfolding on a dust mote suspended in a sunbeam. Historians still argue how long humanity will last. Will our species spread to other worlds, carrying starlight in our technology? Or will we fade quietly, leaving behind only fossils and forgotten satellites orbiting a silent sky? The uncertainty feels less tragic than honest. The cosmos doesn't owe permanence, it offers participation. You realize that to exist, even briefly inside this infinite experiment, is enough. You land softly on a mountaintop, the wind whispering past you. Above, the stars wheel slowly across the sky, ancient and familiar. You've seen them up close, known their fire, yet from here they feel even more sacred. You understand now why humans built myths around them, not because we misunderstood them, but because we recognize something of ourselves in their endurance. You look up and see stories written in constellations, old languages of longing that stretch across millennia. The cosmos is speaking, and for once you understand the accent. A quirky tidbit rises to the surface. Every 7 to 10 years, nearly all the atoms in your body are replaced. Food, air, water, constant renewal. You're literally not the same person you were a decade ago. Matter recycles itself endlessly. Identity is just the pattern it chooses for a while. You grin at the thought that you've been rebuilt countless times from starlight. The universe is apparently very fond of remixing itself. You start to walk, though in this place movement feels more symbolic than physical. Each step takes you through epochs. Mountains rise and erode beneath your feet. Forests bloom, fade, and bloom again. Humanity's cities grow brighter, then dimmer, their light waves scattering upward into the sky. From orbit, Earth must look like a firefly winking at the galaxy. You pause and whisper, "You learned this from the stars." Historians still argue whether intelligence itself is inevitable or an accident. Some say the laws of physics guarantee that consciousness must arise wherever complexity does. Others call it a cosmic fluke, a lucky coincidence of chemistry. But standing here, watching your breath mingle with the starlit air, you suspect both can be true. The universe built minds not because it had to, but because it could. Curiosity is its favourite form of expansion. You lie back on the cold ground and let the stars fill your vision. The sky feels deeper than ever, layered with time. Some of the light reaching you tonight left its home before the Earth existed. You think about how photons travel for billions of years just to end their journey in a pair of human eyes. What an act of devotion, you muse. Maybe light isn't just energy. It's persistence, the universe's way of saying, "I remember." A mainstream note hums gently in your mind. In the final equations of physics, energy is never lost. It only changes form. You smile because you've seen that truth unfold across every chapter of this story, from hydrogen to helium, from stars to life, from fire to thought. You're not apart from that conservation, you are its proof. The light that began long before you were born is still shining through you, refracted as laughter, empathy, and imagination. You take one slow, steady breath, filling your lungs with the same air once inhaled by dinosaurs, poets, and supernovas. You exhale softly, and the mist leaves your lips like a prayer. You've become the echo of everything. Starfire slowed down just enough to call itself human. The thought feels gentle, not grand, and it settles into you like warmth. The wind quiets. The stars above pulse faintly. Somewhere the sun rises again, spilling light across oceans, cities, and sleeping fields. You can almost hear the hum of fusion inside it, the steady promise of another day. You smile, knowing that this is the universe's refrain: energy to matter, matter to memory, memory to wonder. You close your eyes and feel the pulse of your heartbeat sync with the rhythm of the cosmos. It's the same rhythm that beat inside the first star, the same one that will echo in the last. You realize the truth that ties every moment together. You are never separate from the universe. You are the way it dreams,